Assalamualaikum warahmatullahi wabarakatuh. A very good morning to ladies and gentlemen. Welcome to the 4th International Conference on Physics Issues 2024, hosted by Sub-Department of Physics Education, Faculty of Teacher Training and Education at Tadulako University. Well, this year's conference sets out a theme strengthening science and technology by integrating digital and local wisdom in education. This academic forum seeks to foster collaboration among educators, researchers, and policymakers that will ultimately contribute to the advancement of science and technology in a culturally relevant and sustainable manner. My name is Arif, your master of ceremony for today's event. Well, first of all, allow us to offer a warm welcome to our honorable guest, the rector of Tadulako University, this time represented by Doctor of Engineering, Insinyur Andi Rusdin, ST, MT, MSc, the vice rectors of Tadulako University, Deans and Vice Deans of Faculty of Teacher Training and Education, Head of Senate and Senate Secretary of Faculty of Teacher Training and Education, the Head of Institute of Research and Community Service or LPPM, Dean of Faculty of Mathematics and Natural Sciences, Head of Departments and the Secretaries, Professors, the Coordinators of Study Program in Faculty of Teacher Training and Education, the Chairman of Physical Society of Indonesia in Central Sulawesi, Head of Mathematics and Natural Sciences Study Program of Dato Karama State Islamic University, Palu, and lecturers of Physics Study Program, Tadulako University. Well, we also would like to extend appreciation to our distinguished speakers today. Firstly, we have Professor Fatimah Arofiati Nur, and she's here present with us in this building. Welcome, Professor. Secondly, we have Dr. Hasan Ozgur Kapici from Bogazici University, Turkey. Next one, Dr. Chun Yen Chang from National Taiwan Normal University. And the last one, we have Dr. Muhammad Abdul Hadi bin Bunyamin from University Technology, Malaysia. All distinguished speakers, presenters, ladies and gentlemen, before we commence the event, please rise for the national anthem of Indonesia. Please rise for the national anthem of Indonesia.
Di sana aku berdiri, jadi bangku
Please remain standing for the anthem of Tadulako University. Mohon tetap berdiri.
Universitas Tadulako, dia berjuang di baktinya di tengah perguruan tinggi, mengembangkan ilmu dan penelitian, mengerti negara, tujuh cita-cita, sentosa merata di Nusantara. Marilah baik penjunjungnya, insan Tadulako, seragam langkah kita, lestarikan persada ini, berengkas keterbelakangan bangsamu menanti, hadirmu perdamaian, mengkampannya sepanjang sejarah.
All guests, please be seated. As we continue with the agenda, let us take a moment to seek divine guidance and blessings for the success of this conference. In accordance with that, I would like to invite Mr. Muhammad Fajrin to lead the prayer.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let's bow our heads and pray to Allah Subhanahu wa Ta'ala, so He will make this international conference a priceless moment for you all. Please pray with me, for you who hold Islam and for you who hold other religions. You may pray on your own. Alhamdulillahi Rabbil Alamin, hamdan yuafini wa huwa yukafi mazidah. Ya Rabbana lakal hamd kama yanbaghi li jalali karim wa azimi sultani. Allahumma salli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa riyadatan wa ziyadatan fil ilmi wa barakatan fil rizki wa taubatan qablal maut wa rahmatan indal maut wa mahfiratan ba'dal maut. Allahumma fir lana wa liwalidayna walil muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i wal anwar. Inna sami'ul qaribun mujibun datwat ya qadiyal hajats. Allah, today Saturday 7/2024, we gather here to end the 4th International Conference on Physics Issues. For them is strengthening science and technology by integrating digital and local wisdom in education. Ya Allah, may this international conference become a scientific meeting that brings benefit to many parties. Serve as means for sharing ideas, knowledge, and experiment among scholars, research, and students across discipline. May this conference bring benefit to our life, expand knowledge, enrich our thinking, and help us become productive people who will promote the dignity of nation in future. Ya Allah, may you like it and bless us. Help us with our activities. Help us to speak clearly. Help us to listen to each other, respect each other, love each other, and make us among those your blessed. Ya Allah, may your light protect us from any one's depension and sins. So use that what is right and what is wrong is wrong. Let us to do to do good deeds and abstain of the bad deeds. Ya Allah, you are the one answer or your prayer. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Distinguished speakers, presenters, ladies and gentlemen, such an intriguing fact that the physics program of Tadulako University has been accredited with excellent, as it offers cutting-edge research opportunities and state-of-the-art facilities. The ICoPIs is one of the quality products of physics study program, accommodating the idea of combining modern tools with traditional knowledge. While speaking about the conference, it's been a huge pleasure for me to present the stage to Nurul Kamisani MPD as the chair of the ICoPIs 2024 to deliver a welcoming remarks.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, and greetings of Yatu. With gratitude and respect, Rector of Tadulako University, represented by Vice Rector Dr. Engineering Insinyur Andri Usdin STMT MSc, the Chairperson of the Senate of the Faculty of Teacher Training and Education, Dr. Suyuti MPD, Dean of the Faculty of Teacher Training and Education, Dr. J. Vice Dean of the Faculty of Teacher Training and Education, Dr. Rasikin MSE and Dr. Sahrul Sehana MSE. Head of the Department of the Faculty of Teacher Training and Education, Head of the Physics Education Program, Dr. Hayudin MSE, distinguished guests, and fellow participants. We also welcome to our wonderful keynote speakers, Professor Dr. Fatima Alfiati Nur MSE from Institut Teknologi Bandung, Dr. Hasan Oscar Bagusici from University Turkey, Dr. Chun Yan Chang from National Taiwan Normal University, Dr. Muhammad Abdul Hadin bin Bunyamin from University Teknologi Malaysia, and our invited speakers, Misbah SPD MPD and Sadang Hussein SPD MSI, PhD from Lambung Mangkurat University, Dr. Novia MPD from 11 Maret University, Dr. Laifa Ahmawati MPD from Universitas Negeri Yogyakarta, Dr. Hayauddin MSI and Muhammad Zaki MPD from Tadulako University. It is my great honor and pleasure to welcome all of you to the International Conference of Physics Issue, ICoPIs, taking place on September 7 to 8, 2024 at Swiss Bell Hotel. This year's conference focuses on strengthening science and technology by integrating digital and local wisdom in education. As the chairperson, I'm pleased to share a brief report that we are fortunate to have participants from all over the world, representing various academic fields, including physics, physics education, chemistry, chemistry education, biology, biology education, mathematics, mathematics education, STEM education, and many more. We are proud to host 4 keynote speakers and 6 invited speakers. Over the next 2 days, there will be 6 parallel sessions where 32 papers will be presented. Before we begin, I would like to take a moment to express my gratitude to our keynote and invited speakers for taking the time to share the expertise with us. To all the presenters and participants for your commitment and contribution. To our sponsor, the Faculty of Teacher and Training and Education, which give the biggest support financially. To the organizing committee members, Physical Society of Indonesia, and Perkumpulan Pendidikan IPA Indonesia branch in Sulawesi Tengah for your dedication and hard work in making this conference a reality. In conclusion, I hope that this event will serve a collaboration and contribute to the advancement of science and education in meaningful ways. Thank you, and once again, welcome to ICoPIs 2024. I wish you all productive and enriching conference. Assalamualaikum warahmatullahi wabarakatuh.
Distinguished speakers, presenters, ladies and gentlemen, the Faculty of Teacher Training and Education of Tadulako University is really concerned on shaping future educators via promoting practical training opportunities, research, and community to address educational challenges. Next, I would like to invite Dr. Sahrul Saihana, the Vice Dean for Academic Affairs, Faculty of Teacher Training and Education, for a welcoming speech. Right, ladies and gentlemen, let's carry on to the next agenda. Well, it seems like that Tadulako University, as I mentioned, seeks for the international distinction in advancing science and technology with a focus on environmental sustainability. The institution is dedicated to provide excellence in education, promoting collaborative efforts across regional, national, and global spheres. And it's been a great honor to have the presence of Vice Rector for Academic Affairs, Doctor of Engineering, Insinyur Andi Rusdin, STMT, MSc, to deliver a welcoming remarks and officially open the International Conference on Physics Issues 2024.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. All praise to be Allah Subhanahu wa Ta'ala, the one and only God, for the guidance and blessing in making this conference possible. Distinguished keynote speakers, distinguished invited speaker, distinguished guests, respected Senate of the Faculty of Teacher Training and Education, respected Dean of the Faculty of Teacher Training and Education, Vice Deans, Head of Departments, Coordinators of Study Program, esteemed professors and lecturers, and the last but not least, enthusiastic students. On behalf of Tadulako University, it is with great honor that I, a Vice Rector for Academic Affairs, welcome you all to the 4th International Conference of Physics Issues. This conference, organized by dedicated team from Physics Education Study Program of the Faculty of Teacher Training and Education, is a testament to our university commitment to fostering international collaboration and advancing the field of physics. I am particularly delighted to see such a distinguished gathering of keynote speakers today. Professor Dr. Fatima Arufiati Nur from Institut Teknologi Bandung, Dr. Hasan Osgur Kapici from Bogasici University, Dr. Chung Yang Chang from National Taiwan Normal University, and Dr. Muhammad Abdul Hadi bin Bunyamin from University Teknologi Malaysia. Your esteemed presence adds immense value to this conference. The theme of this conference, Strengthening Science and Technology by Integrating Digital and Local Wisdom in Education, is a timely and critical one. As we navigate the rapidly evolving technology landscape, it is imperative that we find ways to harness the power of digital tools while preserving and promoting our rich culture heritage. By integrating local wisdom into educational systems, we can create a more relevant and engaging learning environment and foster a deeper understanding of scientific concepts. This approach not only empower researchers to connect their knowledge to their own experience, but also help to preserve traditional knowledge and practice. To the participants, I encourage you to take full advantage of this opportunity to engage in stimulating discussions, share your research finding, and learn from one another. The exchange of ideas across border is vital for pushing the boundaries of scientific knowledge. To the organizers, I commend that your tireless effort in bringing together this esteemed group of researchers and educators. Your dedication and passion have laid the foundation for a successful, insightful conference. I am confident that the fourth international conference on physics issues will be a resounding success. May it spark new ideas, foster international collaboration, and contribute significantly to the advancement of physics education and research. I now declare the fourth international conference on physics issues officially open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, the Vice Rector, Dr. of Engineering, Senior Andi Rusdin, ST, MSc, for the welcoming remarks and officially open the conference. Well, distinguished speakers, presenters, ladies and gentlemen, next is photo session, but to be preceded with a presentation of souvenir from the Vice Rector for Academic Affairs, Doctor of Engineering, Insinyur Andi Rusdin, ST, MSc, to Professor Dr. Aminah Arofiati Nur. Yeah, I'd like to invite Dr. Andi Rusdin and Professor Fatima to be present in front of the stage for the souvenir presentation. Can we give an applause for Dr. Andi and Professor Fatima? And we expect the next one also. The present presented by the Vice Rector for Academic Affairs. Right, thank you. Let's continue with the photo session. We kindly request the Vice Rectors. Okay, the next one. Yeah, presented by the Vice Dean for General Affairs, Dr. Darsikin. Thank you. Yeah, thank you very much. Next one is, let's continue with the photo session. We kindly request the Vice Rectors, Deans and Vice Deans, Head of Senate and Secretary, Head of Institute of Research Community, Dean of Faculty, Head of Departments, Professors, Coordinators of Study Program, Chairman of Physical Society, Chairman of Indonesian Science Educators, Head of Mathematics, and lecturers of Physics Study to join us on the stage for photo session. Yep, thank you very much, all the guests. We kindly request you to return to your own seat for the next one. Right, distinguished speakers, presenters, ladies and gentlemen, we have come to the end of formal session. And on behalf of the committee, we wish you a very fruitful conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh. We're having the coffee break session right now, and we've allocated 20 minutes for this session. All the things have been prepared by the committee at the back. Hadirin sekalian, kita sekarang di sesi coffee break dan panitia telah menyiapkan segala sesuatunya di bagian belakang. Kami mengundang Bapak Ibu sekalian untuk menikmati kudapan yang sudah disiapkan oleh panitia. Kita akan kembali lagi dengan sesi the main session atau sesi utama dari ICoPIs dalam atau setelah 20 menit lagi. Terima kasih. Ya, Bapak Ibu sekalian, kami mengundang Anda sekalian untuk kembali ke tempat duduk masing-masing karena kita akan melanjutkan dengan agenda utama kita pada hari ini, yaitu sesi conference dan presentasi tentunya. Kita akan mulai kegiatannya dalam waktu 1 menit lagi. Right, ladies and gentlemen, distinguished speakers, presenters, we shall continue with the main session, the first plenary session today. And but before that, we kindly request you to fill out the attendance link that has been sent to the WhatsApp group. Kindly check it out. Okay, ladies and gentlemen, let's continue with the first plenary session. I would like to hand it over to Ms. Mita Aulia Aziza as the moderator to lead the first plenary session of this ICoPIs.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and may peace be upon us all. Distinguished keynote speakers, esteemed participants, and honored guests, welcome to the 4th International Conference on P6 Issues, ICoPIs 2024. I'm Mita Aulia Aziza, and I'm honored to be your moderator for this session. The theme of this year's conference is Strengthening Science and Technology by Integrating Digital and Local Wisdom in Education. This conference provides a platform for academics, researchers, and professionals to discuss the latest developments in science and technology and how digital advancement can be harmonized with local wisdom in education. And for today's keynote session, we are honored to have Professor Dr. Fatima Arafiati Nur, MSc from Institut Teknologi Bandung, Indonesia. So I will welcome for the Professor Dr. Fatima Arafiati Nur, MSc from Institut Teknologi Bandung. Professor Dr. Fatima Arafiati Nur, MSc is a distinguished academic specializing in advanced physics and material technology within a faculty of mathematics and natural science, She earned her doctoral degree from Institut Teknologi Bandung, ITB, Indonesia in 2010. She has contributed significantly to the study of material science with a focus on development of cutting-edge materials in various applications. So we are so excited to hear her insight today. I just want to remind the time limit will be around 55 minutes for presentation and 50 minutes for questions and answer session. Okay. Without further ado, I would like to invite Professor Dr. Fatima Arafiati Nur MSE to deliver her keynote presentation. Professor Fatima, the floor is yours.
Thank you very much for the moderator, the Honorable the Chair and Secretary and member of the Academic Senate Faculty of the Teacher what? Teacher Training and Education, Honorable the Vice Dean for Academic Resources and Students of FKIP, gitu. And then the Honorable the all Head of Department in FKIP, all of the coordinator of the of study program in FKIP, all professors, lecturers, students. Assalamualaikum warahmatullahi wabarakatuh. Okay. Salam sejahtera untuk kita semua. Good morning, ladies and gentlemen. Thank you for giving me a chance to stand here for presenting my project. Okay, maybe I would like to introduce myself again. My name is Fatima Arafiati Nur. I am from Physics and Advanced of Material Technology, Department of Physics, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung. Okay, ladies and gentlemen, it's my very happy task to give you some information about my project. And at this moment, I'll give the presentation about the simulation on electrical properties in nanotransistor devices. Okay, at this moment, maybe I will take about the 60 minutes of your time. I think it's the enough long time, I think. And for my presentation, I have divided into several areas. Please, next. Next. Okay. Firstly, overview of the transistor. In this session, I will explain about what is the transistor and the types of the transistor and the working principle of the transistor. And secondly, MOSFET scaling and its challenges. I will explain about the planar MOSFET and of course with the simulation. And then the design cylindrical surrounding gate MOSFET, including the simulation, and the last one, conclusion. Okay, ladies and gentlemen, let's start to the first session. It is the overview of transistor. Next. Okay, this is the transistor. Transistor is the one of the most important electronic devices in the electronic industry, because almost all in the electronic equipment there is a transistor. For example, in the laptop, computer, and then the household appliance, even in the children toys, there are transistor. So the invention of the transistor is very important for the modernization of the electronic industry and supporting the small electronic devices. For example, for mobile phone, you know, and then laptop. Maybe you know that in this era, we have the small mobile phone for the example. Okay, maybe I will explain about the history of the transistor. Before the invention of the transistor, you know, the first computer in the world, it is the ENIAC, Electronic Numerical Integrator and Computer, use the 18,000 vacuum tubes, which have the weight of the 30 tons, and placed in room of 167 meters square. It is need a large room to put a vacuum tube. Okay, and the electricity consumption of about 174 kilowatts, and the vacuum tubes were replaced daily due to frequently failures. We can imagine that for the last or past computer, we need a large area, we need a large place to put computer and vacuum tube, and it is not very efficient. But now, in the modern era, computer only have microchip in which the microchip contains billions of transistors that replace the function of the vacuum tubes, offering greater durability and more affordable cost. So you can compare, okay? You can make a comparison between the past computer and, for example, and now computer, because this is the technology of the transistor. So we can make conclusion that the transistor is very, very important in the modern technology. Okay, next. Okay, this is the timeline of the invention of the transistor. And after the invention of the vacuum tube, the first transistor was obtained is the type, one of the type of transistor in 1926. So in 1926, field effect transistor was obtained. And following by the another type of transistor, it is the bipolar transistor junction or BJT. Okay, and along the time that the technology of the transistor has developed and to reach the better performance, and until now, I think the research about the transistor has been developed, and I think that it will have the great the great function, or I think it's very important until for the next research. Okay, for our research, we are limited only in transistor. We are only limited for the field effect transistor. Okay, we choose one type of the transistor to be researched. Okay, field effect transistor is one of the type of transistor which is use the voltage or electric field to in its operation. Okay, FET has many applications. There are many electronic devices use the FET. For example, in integrated circuit, IC, display, RFID, gas sensor, biosensor, and artificial nerve. Okay, and the FET or the field effect transistor has become one of the most important inventions supporting the development of electronic devices, particularly integrated circuit. You know that integrated circuit is used in the computer. Okay, for example. Okay, next. Next, okay. There are many kind or type of the transistor FETs. One of the type of the transistor FET is the MOSFET. MOSFET, metal oxide semiconductor field effect transistor, is one of the types of the transistor in which use the material, use the oxide material as insulating layer. What is the function of the oxide material? The oxide material has the function to prevent the leakage current flowing in the transistor. That's the function. Okay, maybe I will show you, the diagram of the transistor FET or MOSFET. Basically, MOSFET consists of several main areas. MOSFET has three terminal connection. They are source, and then drain, and the gate. And the gate is from metal material. And the voltage in the gate controls the current flowing from source to drain, or we can call it as the drain current to the field effect. So in the easy word, that the current flowing in the MOSFET is the drain current, flowing from source to drain. If we have the great green currents or good drain current, so we can say that the MOSFET has the good performance. Okay, and then the another part is the semiconductor channel. This is the semiconductor channel. This channel between source and drain, the place for the drain current flowing. Okay, and then the insulating layer or the electric layer, this one, in the MOSFET, it is used the metal oxide. As I said before, that the metal oxide has a function to prevent or to decrease the leakage current flowing in the MOSFET transistor. Okay, maybe to make easy, we can analogize the working principle of the transistor with the water flowing in the pipe. Okay, you can see this is water flowing in the pipe. There is the source of the water, and then the edge of the pipe, we can analogize with the drain. It means the place where the water come up. Okay, and this is the tap. Okay, we can control the water flowing in the pipe. We can on or off or increase or decrease the water flowing in the tap in the pipe by controlling the tap. Okay, so it's the same with the transistor. We can control the flowing of the current here by regulating the voltage in the gate. So we can stop, on, off, and increase and decrease the current flowing from source to drain by regulating the gate voltage. Maybe it can help you to imagine the working principle of the transistor. Okay, next. Okay, you can see this is the thread line of the transistor, and because of the advancement of the technology of the transistor, and to fulfill the domain of the transistor with its application, so Gordon Moore observed that the number of transistors per inch on an IC doubles every year. It will result in the reduction of dimension of the transistor. Okay, so what is happen if the dimension of the transistor will reduce? So we can see this is the MOSFET transistor. Okay, if the dimension of the transistor reduce, so the metal oxide or silicon dioxide. Oh, I'm sorry, I forget to explain you that for the conventional MOSFET, it is used the silicon dioxide as the material oxide or as the insulating layer or as the dielectric layer. Okay. By reducing the dimension of the transistor, it will cause in the shrinking of the silicon dioxide thickness. Okay. So this condition will result in the unwanted effect. Please enter. Next. Next. Okay. Next. Okay. No. Okay. The leakage current flowing from the gate to the semiconductor will appear, and it will disturb the drain current flowing from the source to drain. You can imagine it? Okay, because the reduction dimension of the transistor, so that the thickness of the silicon dioxide decrease, and it will cause the current flowing from gate to the semiconductor. It is the unwanted current. We want to decrease the leakage current to make higher the drain current. Okay, can you understand? Okay. Okay, I will read it. The current flowing from the source to drain, it's called as the drain current. It is the wanted current. Yeah. If we get the good drain current, so we can call that the transistor has the good performance. Yeah. But the leakage current or tunneling current, which flowing from the gate to the semiconductor, is unwanted current. Why? Because it will disturb the drain current. It will reduce the drain current. Okay. Next. Okay. And it is supported by the experimental data, which is shown by Low in 1997. We can see that the gate leakage current increase as the oxide thickness decreases. Okay, it has proof from the experimental data. So we have to find the solution. How to solve the problem? Okay. One way to solve the problem is to replace the silicon dioxide as the insulating layer by the other material oxide, which has the electric constant higher than the silicon dioxide, which called as the high K material. And the basic idea in using the high K material is from this equation. Maybe it is the simple equation. Maybe you know, on a physics student know this equation. Okay, by using the K or high constant dielectric and reduce the oxide thickness, we can still find the high capacitance, or it means that we can find the good performance of the device. Okay, there are many oxide material candidate to replace the silicon dioxide. For example, like the hafnia dioxide, and then hafnia silicate, and then zirconia dioxide, and many. But one among these candidates, the hafnium silicate, is a high K dielectric material and candidate to replace silicon dioxide, and it's more expected among them. Why? Because hafnium silicate has thermal stabilization, good thermal stabilization, and then has a lower degradation mobility compared to others, and has the good IV characteristic compared to the other oxide material. So, in this simulation, in the device computation, the device computation is used to optimize MOSFET performance by studying the electron transmittance and leakage current or tunneling current. Okay, so now we move to the simulation of the MOSFET. Okay, please next. Okay, firstly, in the right side, you can see, this is the diagram energy of the MOSFET. Maybe we can see that this is the metal, okay? And this one is the high K material, and this one is silicon dioxide, and this one is semiconductor. Firstly, in our model, we have to describe the energy diagram. So, this one is the body height of the high K material, and this one is body height of the silicon dioxide. And the electron flow tunnel through from the metal to the semiconductor. The electron tunnel through from the metal to the semiconductor is called as the tunneling current or leakage current. Okay, please, next. By applying the voltage to the oxide, so we can find the diagram energy like that. Okay, but using, please, next. But using the electrostatic formulation, it's so very simple. We can formulate the equation for each potential energy in each region. So, which is represented by this one. This one is the potential energy, okay? Potential energy for each region. For example, this one is metal and high K material, silicon dioxide, and semiconductor. Okay. Our model was started from the description of the behavior of the electron in the material, which is described in the Hamiltonian equation. Maybe physics study now about the Hamiltonian equation, which is described by this equation, in which P is the momentum, and M0 is the free mass of the electron, and V is the potential energy, and E is the total energy. And the total energy is consists of the longitudinal and transverse energy, like that. Okay. And by using this Schrödinger equation, please next. Okay. We find this equation. This is the potential effective. Why this is appear? Because we consider the total energy consists of the coupling of the transverse and longitudinal energy. So this effective potential can be read in another form like that, and this one is the same as this equation, and from this equation we find the important parameter. It is the electron velocity of the electron. Okay, by using the analytical solution for Schrödinger equation and applying the boundary condition, so it is easy to find the electron transmittance by using this equation. Maybe you know, maybe you have studied in the quantum physics. Yes, maybe you know, familiar with this equation. This is the transmittance in the tunneling process, in the tunneling case. Okay, so from this equation we can find the electron transmittance, and then the obtained electron transmittance were used to calculate the electron tunneling current or electron leakage current, but using this equation. So this is the final of the modeling of the leakage current. Okay, next. So in the model, when we do the model, so we have to check our model with the experiment data to check. To check why? Because we want to know the model is true or not. So to determine that, we have to check it. So we use the experimental data, okay, which given by our college in Japan, okay, and uses this is the several parameter like that, and we use the titanium nitride as the metal gate, and the mass is like that, and then the dielectric constant for the hafnium silicates and silicon dioxide like that. So we input this parameter to the model, to the previous model. Okay. Okay, next. Okay. So, firstly, this is the measured current obtained from the experimental data. And this one is the calculated current obtained from the model. So we have to fit between the calculated current to the experimental one by using fitting parameter, several fitting parameter. What is the fitting parameter? For example, in this case, the fitting parameter is the electron velocity and then the effectiveness of the hafnium silicate. Next. Okay. And we can see by using the fitting parameter and fitting data, we can see that the calculated leakage current from the simulation model is fit well by the experimental data with this fitting parameter. So from this result, we can make conclusion that, oh, the effectiveness of the hafnium silicate is not constant, but it depends on the thickness of the hafnium silicate. And we can know that the electron velocity is constant. It means that it doesn't depend on the electron velocity. And so after doing the fitting data, we can see that the calculated tunneling current or leakage current obtained from the model simulation fit well by the experimental data. Okay. But for the voltage less than a half volt, there is no electron in our model. It can be understood because, please. Okay, because in this area, this is the forbidden place. There is no electron stay here because this is the energy band gap. Okay. Because this is the energy band gap, there is no electron flowing from the gate to the semiconductor. So the reason why in our simulation there is no electron current when the voltage is less than a half volt. And the question is, what is the current from the experimental data? So the current appear in the voltage less than a half volt because it is the whole current which flow from the semiconductor to the metal. Okay, that is the justification, and it has been proved in my another research, but I'm sorry that I didn't show it here. Okay, so next. Okay, after doing the fitting data, so we want to know and we want to calculate the leakage current in the MOSFET. So we calculate the transmittance and leakage current for the variation of the electron velocity and then the thickness of the hafnium silicate. And from this simulation, we can see that the transmittance decreases as the electron velocity increases. And then we find that the leakage current decreases as the oxide voltage is reduced, and the leakage current can be reduced by increasing the thickness of the oxide layer. It means that the leakage current in the transistor MOSFET can be reduced by increasing the electron velocity, by reducing the oxide voltage, and by reducing the oxide thickness. Okay, that is the result from our simulation. Okay, next. Okay, however, the improvement in MOSFET performance through scaling reducing the size of the MOSFET has the approach its limits. So it means that there is at a point that the MOSFET cannot be reduced anymore. To solve the problem, we can modify the geometry of the MOSFET from the planar geometry to the cylindrical one. Okay, and for example, like that. From the planar, this is the planar, okay, the planar MOSFET to be cylindrical one. Why? The cylindrical MOSFET can be as a solution because the cylindrical MOSFET over the better gate control and minimize short channel effect and lower tunneling current or leakage current compared to a planar and with the same thickness. Okay. Next. Okay. And for our research, we use the cylindrical MOSFET by using the gallium nitride as the semiconductor. Why? The gallium nitride-based transistor is promising for next generation power conversion because it offers low on resistance and fast switching rate and high frequency and highly efficient power conversion due to low band gap and high electron mobility. And we can see that there is the potential application for GaN nanotransistor, for example, data center, consumer electronic appliance, and radar. But the bottleneck issue by using the GaN, by using this structure, is the heterojunction structure of HEMS will typically produce stress and strain, and it will result on the spontaneous polarization. Introducing a high-quality cap layer with low surface-related defects under the gate are expected to be efficient to dealing with the polarization effect. Okay, please next. Okay. One of the solutions is by using the GaN nanowire as wrap around gate in GaN FET to reduce the polarization effect. Why? Because the GaN nanowire wire wrap around gate generate enhancement mode operation has the threshold voltage of about the 1.2 volt and on-off current ratio as high as 10 square of 8 and sub-threshold slope as low as about the 68 millivolt per day and drain current up to 314 and transconductance up to 125. And this is the IV characteristic which is obtained by our colleague from Germany. And we can see that this is from the IV characteristic, we can see that the drain current show the nonlinear behavior for the low voltage regime. But the observed maximum current in the high voltage regime has remained unclear. So this appear the maximum current, and it is not unclear. We want to know why it's happened the maximum current, why it's happened the nonlinear current. Okay, so in conclusion, that there is not available a simple model which explains the phenomenon of the nonlinear current behavior in GaN nanowire. So such a model is urgently required to gain new physical insight into GaN nanowire transistor and to further optimize the design and fabrication. It's the reason why it is important to do simulation to know what is the physical meaning in the device. Okay, next. Okay, so by doing this simulation, we do this simulation for two types of GaN nanowire. Why? We used to tap this GaN nanowire because we have the experimental data. Okay, the experimental data, as I said before, that is done by our colleague in Germany. Okay, we use the GaN FET silicon dioxide. It means that it is used the silicon dioxide as the oxide material, and another one is GaN FET aluminum trioxide. Okay. Please next. Okay, now we move to the simulation, analytical simulation. Okay, maybe it will make confused. Okay, we start with the theoretical model for the cylindrical GaN nanowire. Okay, firstly, we have to consider the GaN nanowire as the one-dimensional wires with two reservoirs at each end, in which the source and drain are considered as a reservoir, and the gate length is the same as the channel length. So that the current inside the wire, based on the robotical work, as shown in this equation, in which this is the channel current, and this one is the conductance quantum, and this one is the transmittance. This one is the difference of the quasi-Fermi level, and Q is the electronic charge. Okay, and the conductance quantum G0 is represented by this equation, in which this is the density of the state, DOS. And for the case of one-dimensional wire, the conductance quantum is like that, in which for the one-dimensional wire case, the conductance quantum is constant. Okay. Next. In our case, into the device, maybe we can call it as the U device for the silicon dioxide-based GaN nanowire transistor, and Fatahillah device for the alumina oxide GaN nano transistor. The slope of the IV curve varies depending on the gate source voltage, and it is result in the GO, or the quantum conductance, is not constant. So that for our case, the GaN FET-based silicon dioxide and alumina dioxide-based GaN FET are not pure one-dimensional case. Okay, based on our investigation, so we formulate the quantum conductance for the silicon dioxide-based GaN FET device, and this one for the another devices. Okay, we can see that for the GaN FET silicon dioxide structure has a similar effect to diode, where the junction creates built-in potential. And the difference with GaN FET silicon dioxide case is that its potential is controlled by the gate source potential. Okay, thus the mu, delta mu, or the difference of the quasi Next. Okay. So, yes, okay. So, after that, we find the transmission coefficient with this equation. In this study, transmittance has a similar form to the Fermi direct distribution. Maybe you know maybe the Fermi direct distribution in statistical physics. You have learned about that, okay? And in general, P, the parameter of P, will be composed of the surface potential function of the device that cause a potential energy barrier for electron in the channel. Even so, where the gate length is not too short, in silicon dioxide-based GaN FET device, the electron interaction with the surface potential becomes important and numerically close to the gradient channel approximation model. And so for this device, silicon dioxide-based GaN FET, we can make this equation like that, where the IV term before saturation follows the parabolic function, in which that the lambda, parameter of lambda, more or less than 1, and the current inside the wire becomes similar to GCA model. Okay. Next. Okay. The consequence of the built-in potential, which is controlled by the gate source potential, also impact the current in the previous equation, producing a ohmic condition in the IV characteristic, causing nonlinear behavior in current. That is the reason why there is the nonlinear behavior appear in the experimental data. Okay, the current due to channel conductance, which can be confirmed with this equation, and meanwhile in MOSFET, the current should approach saturation as a drain voltage approaching infinity. Then the total current with nonlinear behavior can be calculated by using this equation. Okay. In the case of the silicon dioxide GaN FET and alumina trioxide GaN FET devices, due to scattering effect, the saturation current could be described as follows, as this equation. This is the gamma, the important parameter. Gamma is the fitting parameter for transmission coefficient, in which we can define that if the gamma less than 1, then it is the quasi-ballistic. but is gamma is equal. The one, it's the ballistic case. Okay. Next. Okay, the max, previous please. The previous like, okay. The maximum current occurred when the current due to channel conductance is 0. Okay, and we can find this one. This is the drain voltage maximum with this formulation, and this what is the Lambert wave function. And for the quasi-ballistic case, maximum current is represented with this equation, and based on our investigation data, the built-in potential model is like that for the silicon gallium nitride device. But for the aluminum trioxide GaN FET with the has the shortened gauge with compared to the silicon dioxide GaN nanowire, we find this formulation. Okay, we do the main approximation. Okay, next. Okay, from the analytical and numerical simulation, so we find this figure, this curve. You can see that this one line is the model and the dashed line is the data. Okay, we can see that from this figure, we use the conductance quantum and built-in potential and saturation current for every VGA as the fitting parameter. Okay, and from this result, we can see that this result confirms that the drain current is determined by the determined by the quantum conductance and determined by the built-in potential and saturation current, and also refers that the drain current is not influenced by the electron. Yeah. Okay, from this result, the drain current is not influenced by the mobility of electron, but is influenced by the gate voltage. Okay, the drain current does not increase at the low drain voltage regime. This one. Okay, and our model best fit with experimental data for the drain voltage higher than 2 volt. You can see this is the fit well. The data from the model fit well by the experimental data. Okay, next. Okay, and another result. Okay, so we try to find the maximum current with respect to saturation current for each gate voltage. So we can obtain the result, and from the value of the quantum conductance, built-in potential, and saturation current, maximum current could be determined easily based on condition this one. So we do the expression data of the saturation current and the maximum current information in the figure, and from figure we can find that the gamma is equal to 0.9. It means the gamma is less than 1. The carrier experience a scattering mechanism due to effects in silicon dioxide GaN FET caused by the unintentional doping. And from this result, we can make conclusion that for the device silicon dioxide based GaN FET, it is the quasi-ballistic drain current, not ballistic drain current. Okay, next. Okay, another result. The result saw the model and extracted experimental data for built-in potential. Okay, to determine H parameter from the built-in potential, we find this equation and find the H parameter is like that. Okay, the equation of the built-in potential has a similar effect to the potential resulting from diode junction, and H has the same meaning as this equation. Maybe if you have taken the semiconductor physics course, maybe you know about this equation. Okay, this is the equation for the diode junction. And in this case, the current density may be attributed mainly to the high current density in the accumulated channel due to the unintentional doping. And the high value of the age parameter indicating unintentional doping in the device. Okay. Next. Okay. From the result we obtained previously, so we can find this data. Okay, and then from the conductance and fitting this using quantum conductance by using this equation, and we find previously that the quantum conductance is not constant. This figure confirms that the silicon dioxide GaN FET is not one-dimensional case. Okay, indicated that the gate leakage current cause electron no longer flow in one-dimensional case, and the result confirm our approach for nonlinear behavior current in silicon dioxide GaN FET as almost one-dimensional case. Okay. Next. Okay. Next, this is the last result for the silicon dioxide GaN FET. To support our model, we use the parameter gamma, H, and eta parameter to test the IV characteristic with the experimental data for the drain voltage 6 volt, and this is the IV characteristic. And from the figure, we can find that the IV characteristic from model has a similar pattern to experimental data, except for the accuracy level. And we can see that for the gate voltage higher than 1.2 volt, the predicted drain current value increased compared to the experimental data, result in highly dependent on threshold voltage that explain the model saw earlier increase in current. And we can see that for the transmittance, okay, okay, between the half and 1, getting hysteresis occurs, which was also observed in experimental. It means that it controlled by the gate source voltage. So from this result, we can make conclusion that our proposed model offer an easy way to predict the getting hysteresis through transmission coefficient analysis. I think this is the easy way to find the getting hysteresis. Okay, next. Okay, the recorded nonlinear current indicate a carrier charge trap filling mechanism, and a trap filling mechanism will require a time delay for electron to flow in GaN nanowire from our proposed model like this. And as I explained before, this is the Lambert function, in which in the Lambert function, the time delay case due to the Lambert function. So to prove this case, we assume that the total charge of the trapped electron at any given time like that. So the conclusion from this equation is the drain current propagation affected by charge and delay time. So the memory effect is caused by a time delay current. That is the conclusion from this equation. Okay, next. Okay, we move to another device. It is the 2 alumina trioxide based GaN FET. Okay, the difference between this device with the previous device, silicon dioxide based GaN FET, is in the alumina trioxide based GaN FET has added the magnesium acceptor in the channel and has shorter gate length channel compared to the silicon dioxide GaN FET, and the drain current follows a parabolic function with respect to the drain source voltage. And we can determine the lambda, the parameter of lambda for this device. Okay, from the result, the optimum values for a lambda and p-value are reached when the difference between saturation current data and the saturation current for each gate voltage has the lowest deviation. And the optimum value, we can find the lambda is this. Okay, and p we can find from this. So the conclusion is the alumina trioxide based GaN FET has relatively constant P with respect to the variation of the gate voltage, where the gate has a short length. Next. Okay. And then this is the result, fitting data, from the model, and then experimental data, and the extracted data. And from this figure, from this calculation, we can make conclusion that there is no maximum current because gamma is equal to 1. It means that this is the ballistic case. It's different case with the previous device. So the mean free path becomes very large relative to the channel. So from this simulation, we can make conclusion that by shortening the gate length of MOSFET will result in increase the mean free path and will enhance the transmission coefficient, of course. Okay, the parabolic trend line indicate the three-dimensional linear dispersion dose represent dominant scattering caused by the magnesium. So in this device, in aluminum trioxide, from the result, we can find that this is the ballistic case. Why the ballistic case appear in this device? Because it maybe it caused because the in potential doping of magnesium. Okay, so that is the calculated result of the simulation. I think maybe it's make confused. Say, I know because when I do this simulation, of course confused because we use both analytical and numerical approach. Okay, yes. Okay, the last slide, I think, conclusion. Okay, by studying from the simulation, analytical or numerical, we can make conclusion that by studying how to design, optimize, and simulate the performance of this device is key to the advancing of the latest technology. And the device characteristic can be modified by engineering the oxide layer material. And we found that the performance of the gallium nitride nanowire transistor depend on the selected oxide layer material, and the different current characteristic for different oxide layer material induce the built-in potential depend on the gate source voltage. And the next conclusion is the drain current is not affected by the electron mobility of the GaN material, but strongly affected by the gate length. Reducing gate length for GaN nanowire in transistor will increase the transmission coefficient inside the channel. The memory effect of the device is attributed to a time delay current, and the most important thing that the model can predict the existing physical phenomena in the device and is suitable for determining the characteristic of the transistor prior to further device fabrication. Okay, that's my presentation. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
So thank you very much, Professor Fatima, for the insightful presentation. And now we will move to the questions and answer session. So if you have any questions, feel free to raise your hand and move to the forward to ask your questions. Okay, please move to the forward. Yes.
Test. Okay. Good morning, everyone. Good morning for academical CVDs. It's been honor to be here. Thank you for the occasion. And let me introduce myself first. My name is Brian Muhammad Larate, and I'm from Physics Education Study Program, Tadulako University. and welcome, Professor, to Paulo Town. And actually, to be honest, um, I'm here. Maybe my question is out of your explanation content, your presentation content. Um, the thing which drive me to stand here because I want to bring some points. The first point is I don't want to ask about your content because for honestly I I didn't get just some of your content. Um, I just want to ask about fundamental thing, and the first one is about this event. It's called International Congress Physics Issues. As we know, like our study program have a desire to be study program which is have a desire for become a study program at international level. But for me, it seems like delusional, you know, like like to be sorry, like I'm so sorry for saying this, like to be honest, Miss Professor, like I guarantee just some just view people and hey can catch what your explanation. Yeah, because I'm sorry to say, like I see them like it's not that good in English, like maybe it's quite terrible in English. That's why, like when I when I s- when I see like our lecturer, our bureaucrat say they want to be international level study program, it seems like quite delusional for me. Like, yeah, even for mastering the tool for become international level, they didn't get it. They didn't master it. Like it's English. It's a tool for understand. And the second point is like uh, I'm quite nervous. um, yeah, there's this even it's called international conference physics issues. But I see in my study program they never comply to what's it called physics issues today. Like there's a research it's doing it's did in 2000 if I don't mistake is in March 2021 from researcher from Hungarian, and they finding the fifth fundamental force. I never see they talk about it. They discuss about it. Even it's happened is like 3 years ago, but until now they didn't. I never see they discuss about it, the fifth force. And if we see there is a forum, it's in America. It's called Institute of Arts and Ideas. There is so many speakers, so many good speakers. Like there is a Nobel laureate like Roger Penrose. Yeah, it's really expert on quantum physics. And Michio Kaku from New York University. There's a theoretical physicist. They always talking about the physics, the up-to-date physics issue. But like string theory, multiverse theory, but yeah, as I said before, I never see that in my study program. It's quite unfortunate. Like, yeah, that's some of my points. So, I just want to be hear your response about my points. So, thank you for your attention and tremendous thanks.
Okay, Professor Fatima, please feel free to respond.
Thank you very much for your, maybe it's too hard, maybe, yeah? Not question. And I understand, I know that maybe many of you that don't understand what I said. I think it's okay because we are different subject. Okay, yeah, firstly, gitu. But the important thing in my presentation, or maybe for not only for me, but for the other speakers, the important thing that you can catch the point. What is the point? As I explained before, when we have the problem, we find the solution. For example, in my case, how to reduce the leakage current? We have to find the solution. The solution is to replace the oxide material in the transistor. Something like that. Of course, it's different with your subject. But the important point is we have to learn and to think, overthink, to find the solution of the problem. That is the important thing, I think. Yes, maybe for this, maybe my presentation is not sweet with the theme of the conference, I think. Okay, I realize it, yeah. But I want to deliver to you about mindset, and you can catch the important learning is to try and, I derive the equation, I do the simulation, it's the hard working. Okay, and in every achievement will be achieved by the hard working. If you don't anything, if you hear the, maybe if you observe or hear the presentation and you don't understand, it's okay. It's sign that your brain is running. It's okay, I think. But in every matter, we have to catch the important point like that. How to solve the problem, how to thinking, how to you're working hard, I think, something like that. And it is no matter, I think, if you don't understand what I presented, I have guessed it. It's okay. Gitu. Maybe that's the advice from me, like for you. And I hope that maybe you can catch my my meaning. Okay, thank you very much for your curhat. Okay, maybe I think my presentation is too long. 1 hour. Thank you very much for giving me an opportunity to present my research. Thank you. You know that Dr. Sahrul and Dr. Darsikin is my friends. We were student in ITB. When Dr. Darsikin was doctoral student, I was bachelor student like you. And Dr. Sahrul is my friend in doctoral student, and we are one supervisor, Professor Herijal. So thank you very much for inviting me, and I'm so very happy to know you all and can share my experience and my research. Thank you very much. Okay.
Very much. Thank you very much for Professor Fatima. I would like to once again express our deepest gratitude to Professor Dr. Fatima Arafiati Nur, MSc, for sharing her valuable knowledge and expertise for us. Thank you as well to all participants for your thoughtful questions and active participation. I'm Nita Aulia Aziza as your moderator for this session, signing off. I wish you all the productive and insightful day as we continue with the next session of this conference. And thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Yeah, once again, we would like to extend our appreciation to firstly Ms. Mita Aulia Aziza for leading out the very first session, and also Professor Fatima Rofiatunur for such an insightful presentation about the materials. Okay, ladies and gentlemen, we shall carry on with the second plenary session for today's conference. Now I'd like to invite Ms. Ni Badewiwik Astuti, who's probably joining us virtually currently. Oh, I can see you right there. Hi there. Good morning.
Hi.
Okay, so I'll hand it over to you, Ms. Nima Dewiwik Astuti. Over to you. Thank you.
Thank you so much, Mr. I don't know who, but thank you so much. Yeah, let's just start this session. Okay, hi everyone. My name is Nima Dewi Astuti. You can just address me as Wiwi. I will be serving as the moderator for this session. And before I start, I would like to use this opportunity to express my gratitude to all the committees of the ICoPIs to make this event possible. I know how hard it was, but congratulations, and look like time flies so fast. It has been the fourth time ICoPIs, and I'm so happy to be involved in this inspiring event. Thank you for coming or joining this session. Good morning for those who are joining online or in person in Indonesia. And good morning to Dr. Hasan Ozgur Kapuji. Please correct me if I'm wrong. I don't want to address you incorrectly.
No,
That's
great. It's correct. Yes. Good morning
Yeah.
from Istanbul.
Yeah, so it's really early in the morning. Am I correct?
Yes, it's around 6 a.m. here.
6 a.m. Thank you so much for agreeing to be involved in this event. And it's
welcome.
weekend, so it's mean a lot to us.
Mhm.
So
I am sorry if I look like sleepy. Don't worry, I am okay.
Okay, we'll understand it. Thank you so much just for agreeing to be involved in this event. Really, it's helped us a lot. So Dr. Hasan is a researcher in science education in Bogazici University.
Boğaziçi.
Bogazici, yeah,
Mhm.
University, Turkey, and currently a postdoctoral fellow at Ludwig Maximilians Universität Machen. Oh my God, it's so difficult to pronounce. I hope I don't make significant mistake in pronunciation. Specializing in basic education, and he completed his PhD in science education at Yildiz Technical University in 2021. Following a Master of Science from Istanbul University in 2014 and Bachelor in Science from Bogazici University in 2011. And his research mainly focused on inquiry-based learning, computer-based environments, and pre-service science teachers education. He had led multiple TÜBİTAK-funded projects. So TÜBİTAK is a national scientific and technological institution in Turkey. The project includes studies on inquiry-based learning environment and virtual platform science teaching. And Dr. Hasan has published extensively in reputable journals with research exploring the effectiveness of hands-on and virtual laboratories and their influence on students' learning outcome. His contribution to science education are recognized internationally with numerous citations and membership in leading academic associations, such as the European Association for Research and Learning and Instruction and the European Science Education Research Association. The theme of this conference this time is about strengthening science and technology by integrating digital and local wisdom in education. So in today's presentation, Dr. Hasan will talk about Virtum V, the development of Android integrated instruction media, teaching materials, and higher order thinking skill questions on the topic of quantum phenomena for senior high schools. So this topic, I believe, will be very relevant with the contemporary condition where the students are really attached with their gadget or phones. So learning how to engage these devices will be really helpful in learning process. For this session, we have 1 hour. So the presentation will be around 50 minutes or less, and then followed by the Q&A session. And for participants who want to ask question, feel free to drop your question on the chat box anytime during Dr. Hassan still present their material, their topic, or you can raise your hand with the feature provided on Zoom. And I have someone in the hotel right now can help me to accommodate the discussion. And I will let you to ask the question directly to the speaker during the Q&A session. So without further ado, I hand it over to you, Dr. Hassan.
Sorry?
Can I hand it over to you now? Are you ready?
Yeah, I'm ready. Yeah, everything's okay.
Time is yours. Yep, excellent.
Yes, can you see my screen?
Yes, excellent.
Okay. First of all, as we introduced, my name is Hasan Özgür Kapıcı from Istanbul, Turkey. I work in the Department of Maths and Science Education at Boğaziçi University. Today, I would like to talk about how to increase the efficiency of inquiry learning in computer-based learning environments. I would like to talk more about this. And we should also talk about how we can design the computer-based learning environments to increase the effectiveness of inquiry learning. It's a little bit theoretical presentation rather than presenting the findings of a study. Maybe this can allow us to make more discussion about the topic. This is the roadmap that I would like to follow today. First of all, I would like to talk about the issue, the problem in physics education or generally in science education. And then I would like to talk about the inquiry learning as a solution offer concerning the problem. After that, I will a little bit talk about how we can make the inquiry effective, feasible, or easier to implement in science classes, in physics classes. And in the end, I would like to talk about how we can use instructional technology to make it more feasible in learning class in science classes or physics classes. First of all, I would like to talk about the problem, the issue. As you know, most of the teachers at schools want their students to understand the topics, the subjects. However, from the studies, we can see that in some cases, or in most cases, it is difficult for students to understand the concepts meaningfully, deeply. And this is the one of the biggest problems in educational area, in educational research or studies. And for years, educational researchers, teachers, or instructional material developers have been trying to develop new models, new theoretical frameworks, or learning approach to deal with this problem, how to help students to understand the concepts deeply rather than memorizing it. And recently, in the related literature, we can see that engaged learning can be a possible solution for this problem. Of course, we cannot say that engaged learning is 100% answer to the problem. However, when we compare the effectiveness of different learning approaches, engaged learning can be a possible or better choice when we compare it to the other learning approach. Furthermore, when we consider the effectiveness of instructional technology, it also helps us to use engaged learning in science classes better and easily. Because instructional technology has been developing rapidly, and it really can be useful for us to help our students to be engaged in learning activities in science or physics classes. Then let's talk about what is engaged learning. This is a very general definition of engaged learning. Any form of learning in which students are engaged in transforming or creating content or discussing or reflecting on knowledge and skills. Very generally, we can say that engaged learning is a kind of learning in which students are active through learning process. They are mindfully and physically active through the learning process. We can call such kind of learning approaches as engaged learning. In other words, students engaged learning is a learning method or approach in which students are active participants of learning process. Also, some studies from the literature also show that engaged learning increases students' performance in STEM education. That's why meta-analysis studies, or there are some more studies in the literature that shows us that engaged learning approaches increases the students' learning outcomes, their conceptual understanding, their inquiry skills, their motivation for learning science or physics. This is one of the meta-analysis studies I found from the literature. In this study, the citation is given below. In this study, the researchers compared the results, or examined the results of 225 studies in the literature. And then they reached a conclusion that if students are active participants of learning process, if they try to construct their own knowledge, at the end, this will cause the increasement of their conceptual understanding, their meaningful understanding. Furthermore, when we compare the students who were taught in traditional lectures, they are 1.5 times more likely to fail than the students in active learning classes, which means that when students are actively constructing their knowledge and their conceptual understanding, for example, through experimentation process, through questioning or designing investigation environment, they learn 1.5 times more than the students who receive the information passively in traditional classrooms. Of course, there are different types of engaged learning. It's a very umbrella term. For example, these are some different types of engaged learning. However, today we are going to focus on, or I would like to focus on, inquiry learning as a type of engaged learning. Then let's talk more about the inquiry learning. Why I would like to choose inquiry learning as an engaged learning approach or type? because it's very common and very useful in educational studies, in science education or physics education. What is it? Uh, when we look at when we compare the traditional learning approach and inquiry learning approach, we can state some basic differences between these two approaches. For example, in a traditional approach or expository methods, uh, teachers are more active during the teaching process. They explain the topics. They mostly spend their time while explaining the subjects in the classroom time. And students just solve the problems, basic multiple choice problems or true false problems, which don't force students to think critically or to reflect their understanding. However, in inquiry methods learning environment, students are more active than the students in general or usual classroom environment. First of all, of course, we can discuss the level of inquiry in inquiry learning environments. However, in this kind of environments, students can pose their own research questions, or questions can be given by the teacher, and students can design the experimental environment concerning the question. However, what can be, whatever the level of inquiry, the result is the same. Students are more active. For example, in traditional learning environments, as we mentioned before, teachers mostly present the content, and students mostly do experiments just to verify this basic scientific principles. However, in inquiry learning environments, students do experiments to reach a meaningful conclusion, to find an answer for their research questions. They are given a research question, just a simple research question, of course, concerning the middle school curriculum or high school curriculum. And they try to do experiments, and they try to reach results and make inferences from the results of that experiments to understand the topic. In other words, they construct their own knowledge. They try to understand the topics by themselves. Of course, the help of teacher. We cannot ignore the role of teacher in inquiry-based learning environment. I will also talk about this issue through the end of the presentation. And what are the features of inquiry learning? As we mentioned before, learners try to answer scientifically oriented questions. If your students are naive students, if they are not familiar with the inquiry learning approach, then questions can be provided by the teachers. And then students collect evidence by actively performing experiments. Of course, as teachers, we can give some hints, some guidance to students to design their experiments concerning the research problem. However, students mostly design their own experiments environment, their own investigations to find an answer for their research questions. They collect data. After that, when they collected data, they try to make an explanation, plausible explanation, based on the results of their experiments. And then they share their experiments to compare with the others' results. And then they can reach, or they can see the other possible explanations, alternative explanations. And then they learn how to support their conclusion by using the evidence they gathered from experiments. But as a total, as a whole, we can see that inquiry learning method is a method or is a pathway followed by scientists. There is a problem, students design an experiment to find an answer for the problem. They collect data and analyze it. They compare their results with the others, and then in the end, they present their findings, their knowledge by using the data as a evidence. It is a, of course, it's in school science environments. We will use the simple version of inquiry learning at the beginning if our students are not familiar with inquiry learning. But when they get familiar with the inquiry learning approach, then we can increase the freedom of students. For example, we can allow them to pose their own research questions, or we can allow them to develop their own hypothesis at the beginning of the experiment. But this, of course, depends on the student's situation, condition. Then, yes, is inquiry learning effective? Of course, we will check the international journals to see the efficiency of inquiry learning, because in international journals, we can see that there are thousands or many publications which compare the effects of inquiry-based learning with the other learning approach. This is the basic structure of studies, or basic structure of studies to compare the inquiry learning with the direct instruction. And of course, we firstly measure the student's initial condition. And if there is no significant difference at the beginning of the study, then we follow the different learning approach to teach the same topic. And then in the end, we do the same or parallel tests to compare the outcomes of our investigation method or our teaching method. And in addition, we can check the PISA surveys. The first one is international publications, and the second one is PISA surveys, because the questions in PISA really appropriate the measure students' understanding. And I just take the results of PISA 15. I didn't update it due to the COVID process, but last year, if I'm not mistaken, the recent PISA results were announced after the COVID process, and it also has different advantages or disadvantages. But for the presentation today, I would like to talk about why I would like to choose PISA results for this presentation, because it involves data from real students in real classrooms. And then there were a huge number of students in the PISA, more than half a million. That's why this can give us more generalizable results in the end. However, the basic disadvantages, it is just based on student reporting. And it is difficult for us to observe more than a million students in their real classroom environments. That's why we just have to believe on their speech, their reporting. And in addition, we don't know whether teachers really qualified for implement inquiry learning in their classes. That's why we don't know the quality of instruction. However, when we examine the results of literature, experimental studies, we can see that inquiry learning is effective when compared to direct instruction. Here, we should take into consider that inquiry learning is effective when the appropriate guidance is supported by the teachers or by the computer-based learning environments. It means that just the highest level of inquiry is I cannot say that, or the results don't say that the higher level of inquiry is better than the direct instruction. Inquiry learning is successful or better than the traditional learning approach if the appropriate guidance provided by the teacher or by the learning environment. These are some meta-analysis studies from the literature which shows that, yes, really inquiry learning is effective when compared to traditional approach. However, as I mentioned here, independent inquiry, yani, in other words, the higher level of inquiry or providing too much freedom for students in the learning environment is associated with lower learning outcomes. That's why if we want to increase the efficiency of inquiry learning, we should provide appropriate guidance to students in inquiry-based learning environments. PISA results also shows us the same direction, similar results. Inquiry is effective, but when it is supported and when there's a good link with the direct instruction. In other words, this is also called as guided inquiry learning. I hope I'm able to understand how to increase the efficiency of inquiry learning. The guidance is very important. Then this brings us to another question. Why is the guidance important in inquiry learning? Because when we decrease the level of guidance, the students' success fail. Why? Because guidance help students to overcome the limitations of their working memory. As you know, we have different types of memory in our cognitive structure. Short-term memory or working memory and long-term memory are the two important or two famous types of memory in our cognitive structure. And our working memory has two major restrictions. The first of the limitations of the working memory, only a limited amount of information can be stored. Just a few words can be stored our working memory. Its storage limit is its storage is very limited. The second important limitation of our working memory, content knowledge cannot stay there for a longer time. It is possible to forget the information in our working memory if we don't repeat it. That's why we should help students to overcome these two limitations of working memory. Here, the functions of guidance brings us to importance of guidance. Cognitive load theory, which is very important to explain the limitations of working memory, and it also explains how learning occurs in human cognitive structure. This theory also helps us to understand the guidance in inquiry learning environment. Why? Because according to this theory, there are three different types of cognitive load. The extraneous cognitive load, which comes from the learning environment, the learning methods we used, and the learning materials. These cognitive loads caused by the other factors rather than the students or content or the topic. And there are different principles that we have to consider to decrease the extraneous cognitive load. If you know, if you remember, worked examples, split attention, expertise, reversal effect, or there are some other multimedia principles we should take into consider to decrease the extraneous cognitive load. The second types of cognitive load is intrinsic cognitive load, which is caused by the topic. It means that when we increase, if the topic is complex to understand, this means that the intrinsic cognitive load is higher. In the difference between extraneous and intrinsic cognitive load, although the teacher or instructional designer decrease the extraneous cognitive load, as a teacher or researchers, we don't have any function or any role to decrease or increase the intrinsic cognitive load, because intrinsic cognitive load just based on the complexity of the topic. And the last one is germane cognitive load. This is related to creating schema in our brain when during the conceptual understanding process, accommodation, assimilation, adaptation. If you remember from the conceptual understanding process, germane cognitive load, the difficulties students have in his mind through this accommodation, assimilation, and adaptation process. Of course, the germane cognitive load can be decreased by the help of teachers. Based on this, just a brief talk about, of course, cognitive load theory is very extensive and it takes longer hours to discuss it. Here we can see that in order to decrease the extraneous cognitive load and the germane cognitive load, we can use the guidance. Because the addition of extraneous cognitive load, intrinsic cognitive load, and germane cognitive load brings us the total cognitive load. Here, as teachers or researchers, we try to decrease the extraneous cognitive load and germane cognitive load, because on the intrinsic cognitive load, we have no function. In order to decrease these cognitive load, we use guidance in inquiry learning environment. And then lastly, I would like to talk about the guided inquiry in computerized settings, in computer-based learning environments. Because as you know, instructional technology has been developing rapidly, and as teachers, we use or we have started to use instructional technology in our classes, and in some cases we combine inquiry learning and computer-based learning environment, and we just call it inquiry-based, computer-based learning environments. That's why we should also learn how to use guidance in computer-based, inquiry-based, computer-based learning environments. For example, for the initial phases of inquiry cycle, in other words, if you know the 5E approach in the engagement step or in the orientation step of inquiry learning, we can use direct instruction, just text, videos, photos to attract student attention in computer-based learning environments. And also, we should use appropriate guidance tools in different learning environments. For example, these are several tools we can find from the internet-based environment or from the internet, or when we review the articles, we can see such kind of tools that can be used in computer-based learning environments, in inquiry-based, computer-based learning environments. For example, concept mapper. We can use concept mapper at the beginning or end of the inquiry learning process. If we use it in the beginning of the learning process, we can check students' prior knowledge. Or if you want to use it in the end, we can use it as an evaluation tool to whether to check students understand the topic. Hypothesis scratchpad, we use it. I will give an example about this later. Question scratchpad allow us or allow learners, students, to pose their own research or own questions. As teachers, we provide several terms and variables and ask students to pose their own questions to tests in the experiment. As we mentioned before, we should help students while they creating their own questions if they are not familiar with the inquiry learning. Experiment design tool also allows students to determine their independent, dependent, and constant variables. Observation tool, data viewer, quiz tool. Of course, it is difficult to explain these tools in verbally, but if you check the article, then you can see how to use these tools in inquiry-based, computer-based learning environments. And they are really useful and feasible instructional tools. I will just present the hypothesis scratchpad here. But as I mentioned, if you want to learn more about the other tools, then you can go golabs.eu to check, or you can check this article. Then why I would like to introduce the hypothesis scratchpad here, because developing hypothesis is one of the most difficult step of inquiry learning for students. They don't know how to formulate a testable hypothesis, and it's very difficult for especially naive students to develop their own hypothesis at the beginning of experiments. And if we don't if we don't develop a testable hypothesis, then it will bring us to the wrong results. It will also be difficult to design the experiment, and then we are going to fail to collect data and we will reach a wrong conclusion. That's why it's very important at the beginning to have a testable hypothesis. This is the view of hypothesis scratchpad. And here, as teachers, we can provide several conditions. Smaller, increases, decreases, larger than, smaller than, equal to, or something like that. We will also provide variables here, length, mass, time. Of course, these are changeable based on the content of our study. And then students just drag and drop. They use drag and drop method to create their own hypothesis. This is a kind of guidance because guidance does not mean that doing everything instead of students. We just here provide the concepts and the variables and ask students to develop their own hypothesis. In addition, or in other case, we can also provide some half of hypothesis here and ask students to complete the hypothesis. This is another type of guidance. It is a little bit more structured guidance because, for example, if the number of bulbs increases in a serial circuit, comma, then leave blank and ask students to complete the hypothesis. If we increase the number of serial lamps in a circuit, serially connected circuit, then the brightness of lamp increases or decreases. Students will decide it. That's why we can change the amount of guidance based on students' prior experiments, prior experience, or prior knowledge. There is an example study here. It was done by Kuang et al. From China, and they did the study in the Netherlands. And in their study, they compared two different conditions. One of the groups received partial hypothesis, as I mentioned before, if we increase this, blah, blah, blah. The other group just received the variables and the situation, condition. And then these two groups were compared. Again, the experimental group received half of the hypothesis, and they received several conditions and variables. The second group didn't receive any hypothesis, partial hypothesis, but they were just given the same conditions and variables in the hypothesis scratchpad tool. Then ask students to develop their own hypothesis and reach a conclusion. Do your experiments based on your hypothesis, collect data, reach a conclusion, analyze it, and reach a conclusion. And then the results show that students who received a partial hypothesis and a set of terms generated a more complex hypothesis, performed better at data collection, and gained more domain knowledge than students who received just the same set of terms, and from the students who didn't were given partial hypothesis. Why? Because the guidance, the partial hypothesis is a guidance, the difference between these two groups, because the same set of variables and conditions were given to the both groups, but for the experimental condition, partial hypotheses were given. Here, the partial hypothesis decreased the cognitive load of students, and then it helped learners to reach better learning outcomes from the students in the control group. And I think this is the end of my presentations, because I arranged it just 45 minutes, and it's here 6:46. And if you have any questions, then I will try to answer it if I know, because I'm also believe that lifelong learner, and I continue to learn. I hope I was able to explain something about inquiry learning, effectiveness of inquiry learning, and recent instructional materials to increase the effectiveness of it. Thank you very much for your participation and attention.
Thank you so much, Dr. Hassan. So before I proceed to the Q&A session, I just want to confirm about the website for the tools. Is it Go Labs? The Go Labs you mean? Is it the Go Labs and with C.eu? Because
Yes, it was golabz.eu.
yeah.
However, I think it is recently changed to golabs.org, because the it was funded project from European Union, and it's already finished. That's why the EU changed with org.
Yep. Yeah. So I can share the link to the audience in case they want to check what the tools you are talking about. So anyway, I have some question that I have, but before I proceed with my question, I will allow the audience who want to who have question to ask to Dr. Hassan. Yep.
Should I share the screen? Should I stop it?
You can unshare your screen for now, but later if you need.
If someone
like
asks from questions from the presentation, then I can open it again.
Yeah, that will be great. Thank you so much. So anyone from the audience? I believe that Mr. MC will be able to help me accommodating the Q&A session for audience who attend in person. Oh yeah, Ibu Nurjana.
Halo, long time no see. Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, Mr. Hasan.
Hello, but it's a little bit difficult to understand.
It's echoing. It's a bit echoing. But I'll try to help Dr. Hassan.
Okay.
Mhm.
Okay, for the first
Thank you very
time,
much for your. Mhm.
I interested about your presentation about expository method and inquiry method. So you explain how explanatory methods teacher explain and student do exercise. As long as I apply about inquiry methods, I do expository method where teacher explain and student do exercise. So I catch from your presentation how inquiry methods where students do exploration first about the concept and student do design concept.
I'm so sorry, but the it's so noisy now. It's really echoing. So yeah. Is that the same for you, Dr. Hassan? It's really
Yeah, it's a little bit difficult to
noisy,
follow.
echoing, and it's difficult to hear. It's unclear.
Yes. Do you hear me?
It's a bit unclear, but I'll try to catch this time. So can you continue? How inquiry method?
It's about inquiry method.
Yeah.
Mr. Hasan, do you hear me?
No,
It's
difficult. It's
noisy.
really unclear.
Yeah.
Is there another microphone there to use? Maybe.
Oh, yeah. Or maybe on Zoom? Maybe it will be helpful.
Yeah, maybe so the point the point is are there any requirement for students to be able to participate in inquiry methods? So as you explained, students do exploration first about their design and concept with that. Sorry, okay. My point is there any requirements for students to be able to hear? To be able to participate in inquiry methods. Okay, that's it. Thank you, Mr. Hasan, and Assalamualaikum
Thank you very
warahmatullahi
much.
wabarakatuh.
For the second part of the questions, yes, I understood. But if there is different from in the first part of questions, could you please summarize or in the first unclear time part of the question? I think the second part of the questions is there any requirement to help students to be participants in inquiry learning environment?
Yeah, but I
This is the
think that's
question.
yeah, I think that's the question because I think she wants to give the prompt in the beginning, like for example, students need to provide a concept, explain concept and anything. So how to make the students then be able to be involved in this
Familiar with the
yeah.
Okay. Indeed, I can say that there are 4 different types of inquiry, 4 different levels of inquiry, from 0 to 3, 0, 1, 2, 3. If our students are not familiar with inquiry learning approach, then of course we are going to start from the level 0. This means that most of the process guided by the teachers. What does this mean? Teachers give the research questions or hypotheses, and then students give the materials, even sometimes the procedure. And then at the beginning, maybe we can give the results of expected experiments, expected results of the experiments. It's like a traditional instruction. However, when students started to do experiment following the hypothesis or based on their research questions, when they increase their ability, their skills to do experiments, and then when they try to understand the collecting data and analyzing it, we will remove the guidance. Then we can move to the level 1, in which teachers just give the hypothesis and the research question, hypothesis and the materials, and students reach their own conclusion. After that, we can move to the level 2. Teachers just give the problem and students determine the materials they are going to use and the results. And the level 3, the open-ended version, everything will be determined by the students. The research questions, the materials they used in the experiment, the results of the experiment. That's why to make active participants our students in inquiry-based learning environments, we should follow this approach. If you when you consider a graph, the y-axis show the level of inquiry, the x-axis show the content of the subject, content of the unit. Then consider these graph, normal distribution graph. You can consider normal distribution, but half of the normal distribution. It increases like this. When we go on the topic, we increase the inquiry learning, level of inquiry learning. At the beginning, everything will be organized by the teacher. Then we will remove the guidance degree by degree throughout the unit. And when through the end of the semester or through the end of the unit, students will be able to use inquiry more effectively than the beginning time. Is it okay? Clear?
Is it, does Dr. Hassan answer your question, Bu? Yes, quiet means yes, I hope.
Okay, thank you, Mr. Hassan. Is it clear? It is
Thank you.
clear.
Thank you.
Thank you. Thank you so much, Bu. So another question, maybe from the audience, or maybe from people. Oh, that's another.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Ya, Mr. Hassan, I am Mawardin M. Said. M is Muhammad, so my full name is Mawardin Muhammad Said. Yeah, you have explained more about memories. Yeah, especially long-term memories. Psychologically, there are two kinds of memories, namely long-term memory, and short-term memory. The problem of the process of learning and teaching in my institution is the constraints of the students having short-term memories. As you explained about limited capacities of the memories. And if we make research dealing with the memories, I'd like to ask you how to make solution of the problem dealing with unlimited capacities and limited capacities, dealing with the process of making solution by using inquiry learning. That's my problem, and how to make solution, yeah,
Okay.
dealing with limited capacities, yeah, by using inquiry learning. Thank you.
Thank you very much for this question. Yes, as you mentioned, human cognitive structure has two types of memory, short-term memory and long-term memory. However, it is almost impossible, or for recent knowledge, for current knowledge, we cannot increase the capacity of working memory. It is one of the biggest limitations of it we have to deal with. But what can we do? We can use several principles to handle with these limitations. For example, in inquiry learning, we can provide worked examples. Worked examples, it means that the problem given to the students with its answers. And then we ask students, in the next step, we ask students a similar question. But because students have already seen the solution for the similar question, it will be easier for students to solve the question. This is called as worked examples in the literature. For example, another issue can be redundancy effects. This means that instead of using two different representations which carries the same information, we can just use one of these representations. For example, visual, image and text. If the image and text involves the same information, then we should prefer to use just one of them. Because when we use these two together, these will cause higher cognitive load, because these two information source will go to visual channel of our humans, our brain's cognitive structure, and this will cause higher cognitive load. This can be another solution. Or another example can be that modality effect. This is another principle, modality effect. It means that providing written text and visual image together, providing visual image and audio explanation is better. Because if we use visual and audio explanation, it will go to different channels in our brain, the brain system, in our cognitive systems, then it will be less cognitive load. It means that's why when we look at something and listening to it, we learn better when we look at something and reading on it. This kind of multimedia principles, these are just three of examples, and these kind of multimedia principles can be integrated into the inquiry learning environments in order to help the limitations of working memory, I can say. Thank you again.
Thank you so much, Dr. Hasan, and I hope that explanation also can answer Bapak Muwardin question. And this discussion is really great, but unfortunately, it's already 12 p.m. Yes, p.m. in Sulawesi right now, and it's 8 in the morning. No, 7 in the morning in
7.
Turkey.
Yeah, 7
and
in the morning.
yeah, so
Thank you, Sam.
yeah, thank you.
You're welcome.
Thank you. So, by that, I would say that the time for this session is over. So I would like to express my gratitude once more to Dr. Hassan um, for agreeing to share his valuable knowledge to us and then provide this grateful discussion. Thank you so much. And before that, I heard that the committee want to share a certificate to Dr. Hassan. So I hand it over to while presenting the certificate, I also want to sign off from my role as the moderator now and then hand it over to Mr. MC. May I? Who will lead the certificate? Should I or Mr. MC?
Okay,
The
right.
voice is
I
closed.
just been informed by the
Uh,
committee that the certificate should be appeared on the screen.
Yep.
Certificate.
Yeah, we can see it.
Okay.
Yeah, so Dr. Hassan's certificate to show our appreciation for your time, valuable time to wake up in the morning and share your knowledge to us. Thank you so much.
Thank you very much for this kind invitation and giving me an opportunity to share my study with you. And I'm although it is too early here, I hope I had limited fail or limited mistake in my presentation, and I will be happy.
That's right.
I will be happy if you have something to understand about the content of my presentation. This is the biggest gift for me. But thank you again for the certificate. Thank you again for your participation. I hope you had a good conference through the day.
Thank you so much, Dr. Hassan, for your kindness. Okay, so before I hand it over again to you, Mr. MC, I would like to use this opportunity to congratulate my forever teacher, Mr. Unggul Wahyono. I heard that this week he got promoted to new title. So I hope with new responsibility he will keep inspiring for his students. Thank you so much. I'm signing off.
Thank you very much. Congratulations to your teacher. Sending our warmest regards from here. Thank you very much once again to Ms. Nima Dewiwik Astuti MED for moderating the second session. The presentation of Dr. Hassan Ozgur Kapici from Bogazici University, Turkey. Huge appreciation. Thank you very much, Dr. Hassan, for the presentation once again. Right, ladies and gentlemen, we're going to have a lunch break for 1 hour, but please be informed that the session, we're going to resume the session at 1 p.m. Thank you, and we will see you soon. Ya, Bapak Ibu. Iya, Bapak Ibu sekalian, sekarang kita berada di sesi makan siang. Silakan Bapak Ibu yang ingin makan siang dan juga kalau ada mungkin yang ingin sholat, silakan. Sepertinya sudah disediakan oleh silakan berhubungan dengan pihak hotel untuk tempat ibadah. Terima kasih. Dan jangan lupa kita akan memulai kembali sesinya pada jam 1 siang. Baik Bapak Ibu, informasi penting bagi dosen-dosen sekalian diundang untuk menuju ke restoran untuk lunch break atau menikmati makan siang. Sedangkan mahasiswa, panitia sudah menyiapkan konsumsi untuk Anda sekalian di ruangan ini. Terima kasih. Ladies and gentlemen, we deeply apologize for the delay as we are having a technical issues. And we shall resume the agenda in about 20 minutes from now. Thank you for your kind attention.
Hello, good afternoon. Good afternoon, Dr. Chunin Chang and Dr. Muhammad Abdul Hadi bin Bunyamin from Malaysia. Hello, are you in a meeting? Hello. Hello, good afternoon, Dr.
Hi.
Chunin Chang.
Hi, good afternoon.
Uh,
Thank you
thank
for
you.
unmute me. Because I was not allowed to use my microphone just a
Okay,
while
okay.
ago. Yes.
Okay,
Okay.
okay. Okay,
Yeah.
okay.
All right.
Right, ladies and gentlemen, we shall continue with the third plenary session of the ICoPIs 2024. And this session will feature two speakers. Firstly, Dr. Chun Nien Chang from National Taiwan Normal University. And secondly, Dr. Muhammad Abdul Hadi bin Bunyamin from University Technology Malaysia. And this session will be moderated by Mr. Hamzah Ramdhani, MPD. Over to you, Mr. Hamzah. Thank you.
Okay, thank you very much. Baik, oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay. Before we start, can you check your sound? Dr. Chunin Chang. Hello, Dr. Chunin Chang.
Hi. Hi, everyone.
Okay, thank you. And Dr. Muhammad Abdul Hadi bin Bunyamin from Malaysia.
Hi, I'm Hadi from Malaysia.
Okay. Okay, we can start now. So good afternoon, everyone, distinguished guests, speakers, and participants. It's my great pleasure to welcome you all to this international conference on physics issues Tadulako University. I'm Hamzah Ramdan, and you can call me Hamzah. And I will be serving as your moderator today. We're honored to have esteemed speakers joining us from Taiwan and Malaysia. They will be sharing their valuable insight and expertise. This seminar was held in a hybrid. Some participants were at the Swiss Bell Hotel in Palu City, and others were online. Okay, everyone from Swiss Bell Hotel Palu City, please say hello to us. I want to hear your voice. Okay, thank you very much. Before the seminar begins, I would like to first greet our presenter, Dr. Chunyan Chang from, wait for Ohio, from National Taiwan Normal University, and Dr. Muhammad Abdul Hadi bin Bunyamin from University Technology Malaysia. I'm so sorry. This is with Dr. Chinin Chang and Dr. Bunyamin. Yeah, Bunyamin, because technical issues. Yeah, maybe we can change the roles. And Dr. Chinin Chang maybe can present for 25 minutes, and after that, the next session, Dr. Bunyamin at the same time, 25 minutes, and after that will be a question and answer session. So please, ladies and gentlemen, listen carefully and prepare some question. Without further ado, let us begin our seminar. Please join me in welcoming Dr. Chun Chang from Taiwan.
All right. Thank you so much for the nice introduction. So, Hamster, so
Yes.
you mean we have 25 minutes to present?
Yes.
Another 25 minutes for question and answers?
We can, let's see the time later.
Right, right. So because originally, I thought the time is from the whole session is from 1 to 3. I mean, your time 1 to 3. So I have 1 to 2, but I just want to make sure for even from 1 to 2, I only present 25 minutes. Is that correct?
Yes. Yes.
Okay.
Okay.
Okay.
Your time 25 minutes for presentation.
Okay, for presentation. All right.
Yes.
Thank you so much. So in this case, so I would like to share my screen.
Okay.
Okay, please allow me to share my screen. So okay. All right. So let me know if you cannot see my share screen. If you can see it, then which means I'm ready to go. I would like to thank you so much for the organizer, Tadaro University, to ask me to do this presentation. So I'm Chen Chen from National Taiwan Normal University. I'm affiliated with Graduate Institute of Science Education and the Department of Earth Sciences. Currently, also a PI of for Institute for Research Excellence in Learning Sciences. So the topic of my keynote today, I would like to introduce, because this is a science and technology conference. So I would like to introduce you a platform called entitled Cloud Classroom, which has been developed by my team for the last 10 years. And I would like to introduce it to you, or all of you, and maybe you can use it in your own classroom, be it learning or teaching situation, or you can even use it for your own research. And it's actually totally free. It's been widely used by many researchers, teachers, students around the world. So I'd like to introduce you. So the reason we are developing this cloud classroom in early 2013 is at that time, many researchers arguing that we are buying too many hardwares for the students for them to use. Remember, in my old time as a student, every classroom is equipped with one television in front of the class, because at that time people thought television will be the next media to deliver the instruction to make students learn. So before TV, maybe it's radio. After TV, of course, we have all the different facility, computer, and then internet come. But every time when we evolve with something new, we try to buy this hardware for the students. But some researchers argue it's actually a waste of money, because the hardware will be obsolete in several years. Okay, within 10 years, everything will be different. So this is why there is a bring your own device, BYOD movement. Like you don't need to buy any device anymore. With internet, with app, with all the software, you can actually develop some good platform. So doesn't matter what kind of hardware evolve or moving fast, you can just use your own device. So this is why in early 2013, my research team has been involved in achieving something we think is very important for students learning. So because this video, okay, so this video showing a professor when they are doing the lecture, then all the students actually feel very, like after 5-10 minutes, so the teachers, they feel that because the students are getting bored 5-10 minutes, so then they cannot really do interactive learning with the teacher. So in Taiwan, we found out that even 88% of Taiwanese college students are silent in the classroom. But however, the students, they are not really silent because they are still learning. They can actually interact with the teachers. But however, because of the culture, they are hesitant to ask. They thought that they don't want to give a teacher, peers a bad impression. They just want to act as a normal student. So this is why in 2013, my team because of the BYOD movement, so we actually developed a platform called Cloud Classroom. This is a totally free instant response system with at least 16 different language. So there's also Bahasa Indonesia. Then we developed that, then many teachers and students use that, especially during the COVID. Then there are also some studies, empirical studies being done. Not even before the start of Cloud Class, I will introduce you to several of them. Then I will finally give you some like a vision regarding what technology or similar tools or other tools like AI tools developed by my team will be moved forward. So because of the time has been cut to 25 minutes, I think I will first very quickly go through this BYOD things. So bring your own devices, like I would say, you just bring your own device. So that will relieve the burden of financial burden to buy students facility. They just bring anything they can bring. So with internet, with appropriate app or platform, then you can do that. So if you're interested in what is a really BYOD, bring your own device, maybe you can check this website. So because of that, I would like to introduce you the Cloud Classroom. So I will skip this several video because of time constraint. So usually it's like this. So it actually originally aimed for a big classroom, but it can right now also be used in small classroom, even virtual classroom, online classroom. The idea behind it is like, it's called instant responses. And of course, we are not the first team to invent this. So if you are familiar with some of the current tools like Kahoot, Quizzo, and others, and they are very similar. It's called instant response system. When in the classroom, in a virtual or real classroom, teacher give a question, then student using, in the old time it's a remote control, but now using smartphone, your own pad, then you can give answers. Then students, teachers can display all the answers. But right now with Starform, you not only for true and false choice items, I believe Kahoot usually carry, the true, false, or multiple choice item. But with Smartform, you can actually also use open-ended question, open even animation the question. So this Cloud Classroom was selected as one of the exemplar institutions by 2019 Horizon Report. So if you know the Horizon Report, it's actually a very influential report all over the world. So every year they publish the Horizon Report. So Cloud Classroom was selected as one of the exemplar projects by Horizon Report. So a very quick PowerPoint regarding how Cloud Classroom compare to all the other familiar instant response systems, including Socrates, Kahoot, Flickr, Quizzes, Truefield in Taiwan. So I would like to let you know that, Cloud Classroom is not also powerful compared to all the others, but compared to all the others, some you need to pay for the advanced version, pro version, that as you can see from this table. Cloud Classroom is totally free, completely free, forever. Not only now, in the past, but also in the future. It's totally free for everyone to use. So I think we are also the same powerful instant response system, because in Taiwan there are some business they want to buy Cloud Classroom, but we don't want to do that because there's a story behind the development of a Cloud Classroom. I don't have time to show to you, but however, I assure you this is a very powerful instant response system. So if you go to the Cloud Classroom, originally if it's a 1 hour presentation, I will do the demo with you. but because of the time limitation, I got only maybe right now only 15 minutes. So I will just quickly introduce the function of the cloud classroom. So here it's a cross-platform. You don't need to download any app. It's a free of charge forever. It's highly interactive, customized to your need, and we have 16 language, of course, including Bahasa Indonesia. I have many doctor student, master student. They are from Indonesia. So if you just type ccr.tw, in Singapore we also have a server that's for especially for Asian country, and also we have a server in mainland China. So the cloud classroom, we got as I mentioned, 16 language. Then you can quickly, if you type ccr.tw, then you can quickly access it using your Facebook or your Google Chrome account. So this is authenticated in Google or Facebook. Then as a teacher, you can have as many classroom as you want. Then student can access your classroom. Yeah, because of the time, I won't be able to do the demo. Demo will spend, it will take a lot of time. So once this is kind of like a teacher's interface. So once teachers get in, they can create as many classroom they want. Then students can express their emotion, like a happy face, angry face, sleeping face, or and teacher can see it. Okay, and the student can also send private message to the teacher. So this really help for the interaction between the teacher and the students. And the student can also, during the class, pose public question to the students. And there are not only true, false, and multiple choice items by the cloud classroom. You can also use, you can also create your open-ended question. And also, we also have animation tests in there. So I won't be able to go into more detail, but I will quickly show you all this. Then after that, teachers can broadcast the result just like the regular instant response system, but you can also do it with open-ended question. Okay. Then students can answer with text or pictures. Then after students answer, very importantly, we leverage on the AI. We can actually group in students based on their open-ended answer. So there is an AI, artificial intelligence tool behind to group students based on their cluster. So the AI is actually just like right now the open AI currently, we actually leverage on BERT and the GPT-2. So the open-ended question we can actually do in semantic clustering to cluster students' answer, open-ended answer into different groups. Then students can do some like a group discussion. So then there are so many different like role swapping. You can selfie to check in. You know which seat are sitting which students. So all these are different the function in a cloud classroom, and it's actually totally free for everyone to use. So if you are interested in using this, so I'm more than happy to give a special workshop for free for everyone to get familiar with this tool. It's been already there for 10 years. So we actually do the workshop right now, not only in Taiwan, but also in Southeast Asia country all over the world. So just try to let students and teachers enjoy that. So after doing this, then teachers, of course, they can download students' record. Then, so a very unique feature of this cloud classroom is we do have I think right now there are at least 10 different animation-based question in the cloud classroom. You can see it by yourself. So all the animation aim to help students to learn. For example, there is also another seesaw collaborative problem-solving animation. As you can see here, one student on the left, one student on the right, they try to work together to do collaborative problem solving. So then teachers can also doing the go into students group to do chat with students. So another function is called the gaming function. We started 5 years ago, I believe, 2018, or 6 years ago. So we turned Cloud Classroom into a gaming instant response system. So I will skip this, okay? So this is a basic analysis regarding how many students, teachers are using the Cloud Classroom all over the world. This is of course, this is 2 years ago, but it's actually increasing, especially in COVID. Okay, all right. So especially during the COVID, we also think about if it's online tool teaching, we also try to move Cloud Classroom to a standalone Cloud Classroom, so we don't need to leverage on Zoom, Google Meet to do all these different things. Okay, so this is currently the worldwide use. Of course, it's heavily used in Asia because it's developed by my team. Okay, if you are interested in the instruction, how to use that, but it's actually quite easy to use. You can just go to www.ccr.tw to have some glimpse on that. Okay, so next, I would like to present you some empirical studies we have been. So it's not only a good learning and teaching tool, it's actually also a very good to do research. So I would like to present you several important studies. So one of the most important study, so this is actually the best practice when you are using Cloud Classroom or instant response system, similar type tool. You ask question, you ask good question. Then you ask students maybe vote, then you do some peer discussion, then you do some clear class discussion. One of the most important, I would say, most influential or most highly cited studies actually by Nobel Prize Carl Wieman in 2011. They actually use instant response system to improve the large enrollment classroom. So this was published in Science. So, but at that time, it's still called clickers. They use clickers instead of right now the modern instant response system, just like Cloud Classroom. So this is how what they have been doing. The published in Science in 2011. So in their study, they found out, of course, this type of tool is actually very good for students to learn, especially to learn the advanced things. Okay, so I'm gonna skip this cartoon because of time constraint. So here with our Cloud Classroom, we also did several. We have also did some studies. So this is one of the study. We give a good question, then student the vote. Then we display the result. Then they do peer discussion. Then they even do hands-on experiment. So it turns out that this because this is a fixed conference. So we did with a Newton first law. Okay. Then after doing vote. Doing discussion, they're also doing these hands-on activities. So which actually really help students to learn. So this is some snapshot on the hands-on activity. So students' learning progress actually all increase because of this instant response system along with the hands-on activity. As you can see from here, the learning progress. So I will do it a little bit quickly here. Okay. Skip some cartoon. So during the COVID, so I also use this Cloud Classroom with my lectures. For example, this is one online tour with a Beijing Normal University. Then we use a tour. Then we also try to ask how students think about this online lecture using with a Cloud Classroom. So this is for another university. Then we ask them if they think the integration of the platform and the Cloud Classroom are good. So this is the result. That's all the students, they think if an online class can be integrated with this kind of tool, it's gonna be very, very good. Okay. All right. So there's another study actually done by my a former doctor student, Bevo Wahono, and also this is published in International Journal of Education in 2021, I believe. So this is also part of his doctor dissertation. Bevo Wahono, he is right now based in University of Denver. So you can also contact him. So this study, he also used cloud classroom. And you can see this is how classroom interact with a hands-on activity. And this is a result. If you are interested, I can also send you the paper regarding how the cloud classroom integrate with that, has a very large effect size on students' learning. Okay, so I will not go into detail because this is my time is I think almost there. Okay, so maybe one final cartoon I can tell. So when I was a kid, Ma said, "Go to your room." Then it's all dark and alone. Then kids nowadays, "Go to your room." Then kids are very happy, right? So I don't have time, but I want to show you finally, okay, the final slide regarding the cloud classroom. We try to doing more encoding question repository, open-ended question assessment. So this is especially right now easy because we have we have the AI, and also I have two doctor students. They are working on that to make the open-ended question assessment more reliable and all this. So finally, I want to introduce you. I know the time is almost there because I started, I think, almost 25 minutes. So I want to show you a final platform we just developed earlier this year, leverage on current AI. So it's also totally free. It's called the IC, AI supported scientific inquiry. Although we call it scientific, but you can do any kind of inquiry, not only AI. So I want to show you. Can you see my screen change to IC? I don't know. Do you see the research team here now? If not, maybe I need, because I changed to another one. So let me try to show you this. I think it's already there. So this is actually done by my doctor student Sui Qirong and the Daidan from originally from Indonesia. So for this, we actually already have Chinese, English, and Urdu because this is my student. But right now we are developing Vietnamese, Bahasa, and also Indian. So you can see my students. So AI actually, this is the backbone. I'm skipping this. So it's the inquiry feature regarding this IC.tw. So right now you can use the English version, but I hope we'll have the Bahasa soon. You just type in IC.tw. Then you can use this for inquiry. Next, teachers can create. Right now there are some sample inquiry in there, but a student can select, but the teachers can also create their inquiry spaces for students to learn using the IC. So the IC is actually a new platform leveraging on AI. It can help students not only learn by themselves, and the teachers can also create some like AI things. So of course, right now, because of a time constraint, I cannot demo the IC to you, but you are more than welcome to use the IC by yourself. So if you also need to do some like if you also want to using it for your own classroom, and if you are also interested in using that, I'm also more than happy to help. So finally, I want to give you a final slide regarding technology and all these online tool, all that. So teacher as a facilitate, we don't want to reinvent the wheel, which means like we thought that we are using technology, we are involved, but actually maybe we are not like this. Okay, so I think that's about it. I hope I finish it in 25 minutes. And thanks again for inviting me to give this short talk. Thank you so much.
Wow, thank you very much, Dr. Chun Chang from Taiwan. Your presentation is very wonderful. Your research has provided us with a deeper understanding about cloud classroom. Okay, Dr. Chun Chang, you know, before I become your moderator, I tried to research about you on Google Scholar, and you have 281 research. Wow, it's so wonderful.
Okay. Thank you. Yeah.
Okay,
So
okay.
yeah, but I need to be frank with you. Like, you know, actually the cloud classroom, although I publish a lot of paper, you know, many of them are in Q1, in Scopus and such. I hate to say this, but you know, although you know all the publication. So if you ask me what's the thing I'm most proud of, I will tell you it's the cloud classroom, and I write out the current IC. So the IC, we also done some workshop with Indonesian teachers and
Yeah.
also India teachers, and we are also doing research along with that. So if your university, anyone, you know, if they are interested in using IC or cloud classroom, we are happy to offer a online workshop, a free online workshop for all the researchers and teachers in the world, because we know it's a good tool. We want everybody can use it. That's our hope.
Okay, thank you very much, Dr. Chun Chang. And after this, we want to know deeper about cloud classroom. Okay, for the next session, for Dr. Bunyamin. Hello, Dr. Bunyamin. Dr. Muhammad Abdul Hadi Bunyamin.
Yes, yes.
Okay, are you ready?
Yeah.
Okay, for 20 minutes, 25 minutes for your presentation. The time is yours.
Okay, a moment. Can you see my slide?
Yes, so clear.
Okay, so clear. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. I'm not sure how many time zones available.
Yeah.
My time, I think we are in the same time, 2:30 p.m. Okay, in Malaysia. Right. So thank you, Pak Hamzah, for inviting me to this session. And today, it's actually my experience of getting some opportunity to work with school teachers, especially on reforming school teaching and learning, where it involves multiple dimensions of physics project-based learning in hybrid environment. So hybrid means there is a combination in online and also face-to-face interaction. Okay, so I'm Hadi. You can call me Hadi from School of Education, University Technology, Malaysia. So basically, this is the overview of my presentation. This is actually my real story of being a school physics teacher. Okay, so it's a combination of multiple dimensions of knowledge involving psychology, sociology, and also the political dimensions of school teaching and learning. Even though, okay, maybe some of us are not really clear on how it plays, how this all play, okay, in the reality, but I will tell you something that it is very interesting for us to know what exactly happened in the reality, where it is not just a single dimension, instead it's a multiple dimension that we need to apply in order to carry out physics project-based learning. So basically it is in integration of experience and practice, theory and research, and also the local wisdom. It means that how we consider the cultural and also the social aspect of physics project-based learning. So this is how the journey started in January 2021, when I went for a long-term professional development program where I need to be a physics teacher. Okay, just imagine being a lecturer at the university, but now I need to be a school teacher. Okay, so I need to be like a school teacher. It means that I need to lower the way I do my work. It is different between university and the school. Okay. However, the intention of being at school is actually for me to understand the real practice, the practical dimensions of school physics teaching and learning. Simply because we know some academics are not really into the practice. The reality happen in the school teaching and learning. So this is really a very good opportunity for any academics, including me, to learn more about the practical dimension of physics teaching and learning. So in this school, I was assigned by the school principal to teach physics for 2 classes that I could name Class A and Class B. So being a physics teacher at a school, it means that I need to start with a very humble ways of teaching and learning and how I can interact with people. Because I am an academic. Going to school, it means that I need to be like a teacher. Okay. So initially, I should say that I tend to follow the norms of the school education. We know that in Malaysia, in Indonesia, or even at some countries in this world, teacher-centered approaches are something that very, very common in the school. And also because we also sometimes or very often prepare students for tests and exams. Okay, so because of the pandemic, okay, some of these teaching and learning activities were held in the online setting. Okay, but at some points during this time when I teach at the school, I have the opportunity to teach in the face-to-face environment. So that's how I call them the hybrid environment of physics teaching and learning, especially for project-based learning. So this is how I try to look into the quality of my teaching. In May 2021, I made a survey about my teaching quality where I give my students Google form for them to fill in the information. Okay, basically because I really want to know how my students think about my teaching. Okay, either they are really happy with me or not, they are not really happy with me. So I need data from them in order for me to know exactly what they think about my teaching. So it is like a teaching rating. The students give the rating to the teacher. And I know that this is something that very uncommon for school teachers to do because simply they think that the students should just follow whatever the teachers did. But for me, as someone who came from the university where every semester the lecturers were assessed by the student to give the teaching rating, so the same spirit I brought to the school where I give my student an opportunity to evaluate me. So this is what I found, right? Something about, in Malay, we call it a prihatin, okay? The caring nature. Yes, it's a quite good response from these students. They, most of them thought that I was caring to them, okay? Probably because I just have 2 classes to take care, to teach them. So it's provide me as a very good focus for these 2 classes. Okay, so there is no problem about the caring nature of the teacher, which is me. Okay, however, when it comes to something more pedagogical, I found that there is a quite distributive between the scale 3 and 4. 4 is the highest, 3 is the second highest. Even though majority of the students still select these 2, the scale 3 and 4. But for me, I think that there's a variation if I compare to the caring nature that I stated just before. So I felt that, okay, there is no worry about the caring nature of the teacher, but it should be a worry on the explanation, the quality of the teaching approach used by a teacher. So what happened is that, okay, I got a new opportunity come in the real practice. In July 2021, the school principal told all the teachers that the State Department will conduct a STEM competition. Okay? And this is for the students to invent a solar oven using the low-cost materials that I will show with you after this. Okay, and I was assigned by the school, okay, with a mentor teacher that I put the name Mrs. Noni, not the real name, and she told me that I could use the competition as a means for students' assessment, which is called the classroom-based assessment, or Pentaksiran Bilik Darjah, PBD. Then I got the idea that why not? If these students involved in this project-based learning in more informal setting, why not I change the way of doing this project-based learning from informal to the formal setting? So change the way I did the project with the students, okay? And Mrs. Noni really support me on conducting this project-based learning in order for me to make some assessment for the students' project and the students' teaching and learning. So what I found, okay, from my conversation with Mrs. Noni, she told me that many teachers not really into the practice of project-based learning. This is something that uncommon for them, okay, because simply they really just focus the students for the tests and the exams. That's what we call the norms of the education in Malaysia and probably in Indonesia. So for me, as someone who came from the university, I'm not really into teaching for the grades, for the tests, for the exams. I really want to educate my students, okay, and expose them with a different kind of learning experience during their school time. So it's really about my personal beliefs that school education should not just about preparing students for the exams. Instead, they will be required, they will be needed to be exposed with different kind of learning experience, especially in conducting project-based learning. So based on the literature, this is what I learned when I made some reading from the literature, is that PJBL, the project-based learning, is the most common pedagogy of STEM and is widely used in STEM teaching and learning. There are a lot of literature saying about these facts, and it's very good because when we did the PJBL, usually the students will produce eventually an artifact. It could be the final report, it could be a product, a tangible product that a student can produce at the end of the process. For instance, they can invent a solar oven, a mini vacuum cleaner, or any kind of prototype of submarine and so on. And if we want to learn more about project-based learning, this is how we have the framework of PJBL from the literature used by Hasni and also Markula and Axela. And this is especially true for science project-based learning. It involves 6 elements: driving questions, learning goals, scientific practices, collaboration, technological tools, and also producing an artifact. So this is how I use the theories, the concepts available in the literature in order for me to guide myself to do the project with my students. And before I officially started this work in mid-July 2021, I made the announcement to these 2 classes that I'm going to do the project with the students, and I provide the reasons for that plan. Because they are not really familiar with project-based learning. When I asked them, almost none of them have experience conducting project-based learning. Almost none. So it's something that, well, is quite surprising for me. Okay, at the age of 16 years old, okay, they have very least experience conducting a project-based learning. So that's how I explain to the students, if you do this project, you could be able to achieve the band 6 in the classroom-based assessment, which is the highest level of achievement for the classroom-based learning. And they can apply the physics concept that they learn during the classes, okay? And also, as I mentioned to you, they will be exposed with different kind of learning experiences when they were in the school education. But I promised to them, because I know they are not really familiar with project-based learning, I promised them I will guide them at any time in implementing the PJBL. This is the dimensions of psychology that a teacher must provide to the students, because this is the first time they conducting the project-based learning. Some students may not really be confident when conducting this project-based learning because they are not really familiar with. So a teacher must provide that guide in order for the students to complete the project until the completion. So this is how I think the psychological support for the students by the teachers are just very important. So this is how the steps by steps in reality, in the practice that I made with the students, okay, I told them they need to do individually because they stay at home during this COVID-19 pandemic. However, I allow them to collaborate with their family members. This is actually the dimension of sociology in the home, at home, okay? Because they only have the family members. They have no friends outside that they can meet. So I allow them, no problem, you can even work with your parents. Okay? And one thing that I give assurance for my students, for every student, I sponsor them with Ringgit Malaysia 10 Ringgit for each of the project. I use my own money to give the assurance for the students. You can do, and I will support financially 10 Ringgit for each of the project. But I ask them if you can reduce the amount of the expenditure for the project and just use the low-cost materials for the project. And they are free to, to choose any kind of project. They can invent a tool, and they can even produce foods. Okay, some of my students produce cakes, but applying the physics concept. So how they can learn physics when they are conducting, or when they are cooking, or even when they are baking the cakes. So there is a lot of physics involved in this application of even food production, or even when they invent a tool like solar oven. Okay, and I required them to produce a proposal before they did the project. It is like at the university level, before we conducting the project, we are required to propose a proposal in order for us to know the plans of the students. So I did the same spirit, the same way of doing at university to the school. And 3 months for completion of the project, they need to report me from time to time during the online classes. Okay. And also at the end of the projects, they will be needing to present to the whole classes. Okay. And there is some, I can say, impedance or some challenges happen during this implementation, especially because the school suddenly decided to go for online exams, something that never happened before because of the pandemic. So, okay, I just say to my student, okay, just stop for a while for this 1 month. We just focus for the exams, okay, and no need to take care of your project at this moment. And we can only restart the project after we complete the exams. So I need to defer to have some adjustment to the original timeline of the project-based learning, where I add 1 month extra for the students to complete the project. Okay, so this is something that the real challenge happened at school when we are to conduct a project-based learning. We can expect there is some challenges, but we know how to mitigate the problem. So this is example of my student project. Okay, this is the solar oven. If you see there, the temperature from 51.4 degrees centigrade to 72.5 centigrade. There is an increase, okay, in terms of the temperature using these very low-cost materials, okay, of inventing a solar oven. And this is a sketch, the diagram, how it is created, okay. And this is something that I think the best project produced by my students. And you maybe want to know who's that particular student. I will share with you about this student, a very good student. Okay, right. So at the end of this project, okay, they will need to make the presentation and the talent show. Okay, and the good thing is that I invited the school principal, okay, to participate in the online presentation. There is a reason why we could and we should consider participating the school principal in this process. Okay, as a school principal, she or he needs to know the talent of the students at his or her school. So it's very good for a teacher to invite, just invite the school principal to see the creativity, the talent, the interest of the students in STEM or in physics in general. Okay, so this, I think, something that I make a politically correct, because I really want the school principal to know exactly the talent of the students. Okay, and some students manage to have the virtual presentation in live presentation. It means in the synchronous. Okay, but well, some others, they produce video records due to the limited time available. So I really think that this is a very important step for me, okay, inviting the school principal to involve with the process, even though some students feel that, wow, a principal just watch us, they become afraid. But I think there's no problem about the principal. He's just very good, she's just very good and really supportive of this kind of initiative at the school. Okay, and this is some of the example. Okay, the model pulley. Okay, pulley is a very common invention in physics. Okay, how they apply the pulley using this, the well. Okay, it's a very popular in many, at the villages in Malaysia, and even maybe in Indonesia, some of them still use it. Okay, but it apply the concept and the application of pulley. Okay, and some students really produce a very good biscuits. Okay, it's very tasty. And I really believe, because when I taste, okay, something that I think, okay, I believe it is produced by the students, not the mother, because the tastes are not really tasteful. So I know that this is produced by the students, okay, because if a mother did that, it should be something that very, very tasteful. Okay, so that's how I measure the originality of this product, or the artifacts produced by my students when they did this one, the projects with the food production. And how this is, I made the assessment for the students. It's kind of holistic assessment. Okay, I put 9 criteria from objective to the video production or the presentation, and I allocate something like not so even percentage of assessment. It depends on how we should put it. Okay, some criterion should just have a very low marks, but some are just very high. It depends on how we value each of these criteria accordingly. Okay, so for me, okay, I really put the STEM physics concept application, they applied on how they can explain the physics behind this project, and I put them at 30%, the most highest, the very highest among other criteria. So it depends on the teachers, okay, how many and how much percentage, how low and how high is the percentage that we want to put for each of these criteria. Okay, so why I say that it's very important for me to have a good relationship with the school principal, okay, because I think that I am going to reward some of the students with the highest grade for the project-based learning. But what I think is that, okay, some of teachers are really afraid of giving the students the highest score. It means that the peak of the achievement. Okay, some teachers are not so, have no courage to do that, because they will be questioned by the district officer, by the school officer, why you put these students with the highest marks? What's your reason? What's the evidence? Okay, politically, we can handle it. Just make the school principal explain to him or her, okay, what's the good about the students? And because I invited the school principal to see the creativity of the students, so that's how I have the buy-in from those people in power. And there is no objection from the school principal that I can give the highest score for some students simply because they have a very, very good product for this project. So In my opinion, if a student really qualified with a very good score, the highest score, we should reward them with the highest grade as something that very according to their real capabilities. But I know some of the teachers are really afraid of giving the highest mark because they are afraid of being questioned by those officers at the district level and also at the school level. Okay, so I hope that you will learn something about how I tackle these issues quite in more political ways. But this is the reality in school, where if we want to solve something that quite complex, we need to have a very good relationship with the people in power, especially the school principal. So this is the lesson learned, okay? Because most of this project-based learning is on the online learning setting, okay? So I'm not really sure what happened at their home, okay? To what level they really involved with this project, because I allow them to work with the family members, okay? And also the limited communication due to the COVID-19 pandemic, they stay home, okay? And also I stay at the school, okay? I cannot have some, home visit and so on. So there's a limited communication between me and the students. But I think that this is how we can bring the multi-dimensionals of project-based learning, where it is actually an integration of multiple knowledge dimensions, especially the psychology, the sociology, and also the school politics even. So I hope that for those pre-service teachers, mahasiswa pendidikan, bakal-bakal guru ya, calon-calon guru, okay, Anda mungkin belum melihat bagaimana ini semua terguna di dalam reality, in the realitas. Okay, but I think that when you're going to school, you will learn that we need to know how to tackle some of this problem very, a very careful way. Okay, dealing with the school principal. Okay, making friends with some other teachers to help us to get the support. This is something that I think when a new teacher come to a school, they need to know how to tackle the issues in the real school. Okay, so really it's about the multi dimensions of knowledge disciplines and the dimensions, because we know that we need to know so many things about project-based learning, not just about the project, but also the psychology, the sociology, and also the politics of the project. And this is actually, I think, the success story about reforming my way of teaching and learning at school. These students are just very special. Back in 2021, when I did this project with that particular classes, the two classes, she is one of the student in my class. Okay, she's really talented. She's a school prefect, an orator, an avid reader, and a student leader sport. Okay, and I found that she's just really interested in doing project, and she even joined the STEM competition, where at that time I was the student advisor appointed by the school principal. Recently, she just completed her study at the pre-university level in Johor in June 2024. It's quite recent. And just yesterday, she told me that she was admitted to the program, the academic program of industrial physics at UTM. I just really proud with this student achievement. She's one of the outcome for this project-based learning that I did with the students at that particular school. She always contacted me to get some advice from me on how she can excel in physics. Okay, and this is something that I really proud with, because she never forget about my work with the students. And I really proud because she was selected as a new student in my university taking industrial physics. So I just said to her, can I make promotion for yourself for this talk? And she just say, Dr. Hadi, no problem. I even become really surprised because you chose me to promote your former students. So with that, I think I'm really proud with what I'm doing with these students in the past. This is, I think, the success story about project-based learning, where a student at the secondary level eventually entered the university, taking physics at the university level. Alhamdulillah. I think I can stop now, okay? Because time is just so near. Again, thank you very much for inviting me. I hope that you will learn something about the complexity in conducting project-based learning, okay? It is not just a single dimension. It involves the psychology, the sociology, the politics of the school. All of this really we need to take care about and learn, especially if we enter a new school. With that, thank you very much again. And if you have questions, let me know and we can discuss more. Thank you very much.
Okay, thank you very much, Dr. Hadi Bunyamin. You have given us a lot of experiences about how PGBL is implemented. I was very impressed and want to know more about the implementation of project-based learning. Okay, ladies and gentlemen, now a Q&A session, and I would like to open the session for the first session. I would like to invite for 2 questioners. Okay, please raise your hand. You can ask to Dr. Chunian Chang or Dr. Hadi Bunyamin from Malaysia.
Can you listen to my voice? Can you listen to my voice?
Your voice is not really clear. Maybe you can go far away. There is another microphone, maybe.
Can you listen to my voice, sir?
Okay. Your voice is clear now. Okay.
Okay. I have 2 questions for Mr. Chun Yen Chang from Taiwan, Chinese Taipei, and Mr. Hadi Bunyamin from Malaysia. The first question is my conclusion about your presentation, Mr. Chan Yun Chang from Chinese Taipei. Is the cloud classroom is very good to use in the world of education in modern era. But you know, in Indonesia, many school in the village areas don't have good facilities and infrastructure at school. For example, they don't have network, don't have laptop and don't have computer. However, schools in city areas have good facilities and infrastructure. Are you have solution for us if one day we will become teacher at schools in village areas? And then what kind of learning is suitable to use for school in village areas? And then what kind of learning appropriate for students with disabilities to use the internet to keep up with the modern era in right now? And then the second question for Mr. Hadi Bunyamin. In modern era, many physics teachers use the AI, and then many students use the chat GPT for education. For example, use AI to STEM project-based learning. How do you view sophistication of technology today? whether it will affect the function of teacher. Teachers have been replaced by AI. Please tell you about your opinion about that. Thanks.
Okay, thank you very much. Can I know your name?
My name is Arnold from Prestige Education. Arnold, sir.
Arnold. Okay, okay. Thank you very much. Okay, for the next questioner. Okay, please, Ibu Uswatun Hasanah. Maybe host can help unmute the microphone.
Okay, thank you so much for the opportunities given to me. Before I give my questions, so my voice is clear?
Yes, your voice so clear.
Okay, thank you so much. So my question is addressed to Mr. Chan Yin Chang. Hello, sir. Your presentation was wonderful, especially regarding a good classroom, which is really needed in the current learning era, right? Okay, however, my question, sir, is what is the level of data security in good classroom and what are the protection measures? Because we know we can log in with using the Facebook and something like that. And of course, the data from this media will be indirectly connected, right? I think this is my question. Thank you so much.
Okay, thank you very much. Okay, just the question. Dr. Chinacheng, you can get a point for the first questions. How cloud classroom is implementing in a remote area maybe, and how the solution.
Right.
Okay. Okay.
Okay. So I think I will frame the question or answer the question in two different ways. So the first one is regarding the cloud classroom being implemented in rural area. I think I'm totally agree with the gentleman there. I think he raised a very good question. When it comes to technology, I think I start this with my talk. Like, you know, when we have technology, you will have all these problems with hardware, software. It won't be able to really being used well in different situations. So I would like to answer the question by, in two different points. The first one is, okay, so if we really want to use cloud classroom in rural area, so we have tried that in Taiwan before, like, if because the cloud classroom itself require two things. The first one is any device which can access internet. Even very limited internet is actually also okay. I remember we tried that, I think it's like almost 10 years ago in a small island in Taiwan. At that time, Wi-Fi, 5G, 4G is not widely accessible. So what we did is like we actually asked one student to actually share his Wi-Fi using Bluetooth. So in that way, some other students can access his or her internet connection. So it turns out like, for 30 to 40 students 10 years ago in a small island in Taiwan, that was 10 years ago. So actually, as long as you have like 5 sharing hotspot, 4 to 5 hotspot, then the cloud classroom can work well already. So I don't really know the situation in Indonesia, current situation, especially in rural area, because I'm not familiar with that. But I think cloud classroom itself is actually require very low band of internet. But of course, you need to bring your own device. So that might be a big problem for some rural or remote area. So, but you know, this kind of problem happen to all the technology. As long as you involve the new technology, be it a pad, computer, notebook, anything, any device, you will encounter this kind of situation with a rural area, village. So here comes to my second answer to your question. I always tell my students, you know, actually the best technology, it's not internet, it's not cloud classroom, it's not computer, it's not the new technology. The best technology is actually your mouse and with your blackboard. So I think another speaker, Dr. Hardy, very young, handsome lecturer, his lecture actually inspire us, like, you know, without any new technology, if you have a good heart, like, you know, he voluntarily, you know, give, you know, financial support his students. This is the best technology. You can beat all the other technology with good heart and with your passion. So of course, the technology, someday the technology itself will come to be resolved, okay? But before that day come, you see, like, your own good teaching without any technology. As long as you have a good heart, you know, like, and you have a good mouse, like here now, okay? And also you have like, you know, then you can teach everything. You don't need cloud classroom, you don't need anything else. So I remember when I came back to NTNU to do my first teaching job, that was almost 30 years ago. I'm an old man now. So I prepared the overhead, okay? You know, the old time overhead, it's a transparent thing. Then you need to have a overhead projector. That day, in a whole day, the electricity was out. I don't have any technology at all. I was panic. Wow, how could I do? I write all my materials on the overhead transparent, but so I panic. So that day I know I rely on technology too much. So to be frank with you, I would say leverage on yourself. That's the best technology you can get. It will not work. It will not work because of electricity out. It will not work, you know, when, you know, things happen. You have yourself, okay? So that comes to my second question. But of course, if you do have some technology, leverage on that. For example, cloud classroom is a highly interactive thing. Many teacher, student use it, and they really love it, especially during COVID, especially during the online here. Okay, so to answer the second lady's question regarding the data protection, all that. So the cloud classroom, the reason we just leverage on the Facebook and the Google, it's like, you know, we don't want to do the you know, authentication. So because Google and the Facebook are widely used all over the world, okay? So because in mainland China, they don't have a Facebook and the Facebook and the Google. We actually use another, we call the QQ. Anyhow, so we don't authenticate, but however, because when you use cloud classroom, your data at cloud classroom are 100% safe. We don't use that at all. We use actually the data in our cloud classroom to improve our system. So in that way, we make sure the cloud classroom can survive for another 10, 15, 20 years. So people always are curious about, hey, Professor Zhang, last year I was in Singapore to give a keynote. So people over there, they were so surprised. They cannot believe, like, you know, why the cloud classroom is free with the same function, very good, why you make it free? There's a sad story behind this. One of the developer, who is my former doctor student, he actually passed away 5 years ago. He was the one, we have 3 persons working on this project together. His name is Yoda Jian. He published a very good paper in you can just Google his paper. Anyhow, he passed away 5 years ago, but his will, before he passed away, he said he want to make cloud classroom forever free for everyone in the world to use, especially for the remote area, for that. So right now, this is why we are actually implementing his will to make it free forever. As long as I'm here, as long as the engineer is actually his best friend back in high school. He is there. We have our pact. We said we are going to make a cloud classroom free forever. So right now you see the new platform IC. We are also going to make it free. I hopefully forever, because I didn't develop it. It's another doctor still in mind. But we hope it's gonna be free for everyone to use. So for you can be I think I can assure you the data, we protect all the data, because when you sign up for the cloud classroom, you actually see how we protect your data. We will protect data, with our best effort. And also, you can be sure, we won't be use your data for research, for anything. We just use it. If something wrong, we want to improve our system. So this is why the cloud classroom is actually the effort actually done by all the users. When you use the cloud classroom, you actually help us to improve the system. So this is why cloud classroom has been there for 11 years now, and we are still evolving. So I hope that answer your question. Thank you.
Okay, thank you very much for the answer, Dr. Chunyan Chan. Arnold and Ibu Usatun Hasanah, your question is answered. And we next to the, okay, do you have any questions? Ibu Usatun Hasanah, it was clear?
Yes, it was clear. Thank you
Okay,
so
thank you.
much, Mr. Ram.
Okay, thank you very much. Okay, for the next question, Dr. Hadi Bunyamin.
Yeah.
Okay, please answer the question.
Okay, thanks for the question asked by one student. He's a student. I'm not sure if he's a student, probably a student. I agree with the importance of AI in order to facilitate the process of doing a project by the students. Okay, but during that time when I was conducting the project, AI is not yet came to Malaysia at that time. Not the era of ChatGPT yet, but I can imagine if I do the same thing now, it could be something that different from the previous. But I not really worry with the existence of AI. For me, there is no worry about it, because the one who will be replaced with AI is actually those who did not use AI wisely. Okay, there is no wrong about the use of AI, but the way we ask the students to use the AI responsibly, okay, in more critical ways, it means that whatever they found, whatever they discovered using the AI should be critically evaluated. What is important, okay, for the student is that they are educated to think critically on whatever provided by the AI information, whatever. Okay, and I think it is a very due time. It is high time for teachers, for educators, for academics to educate students about the importance of having originality of work in whatever. It means that, okay, it's really encouraged, it will be really push the student to think more and more and more, and to become someone who is better than AI. So if we want to exceed the level of AI competencies or capabilities, we should be someone who can evaluate the limitations of AI. Okay, so no worry about AI. I don't think it will replace the functions of a teacher. But I can certainly and quite confident to say, if a teacher did not use AI in more productive way, and I can predict that he or she will be replaced. So don't worry about AI. Okay, we should use it wisely and responsibly, and even we can encourage students to use it. But what is important is for the students to have a very critical thinking, a critical way of thinking of using the information provided by AI. So again, I have no worry about AI because I think that there is no perfection in terms of its existence. There is no perfection in terms of the creation produced by AI. There will always be some deficiencies, some limitations, some weaknesses that a human have the capabilities to determine what actually the limitations of the AI. So it's time for us to wisely use the most valuable gift by the God, which is our brain. The most authentic, I think, the authentic intelligence, okay, created by the God, okay, in the universe, which is our brain. So we should use our brain to evaluate whatever information provided by AI. And by only that, we can exceed the capabilities of AI. Thank you.
Okay, thank you very much, Dr. Hadi Bunyamin. I do agree with you. So nothing can replace teacher because teacher have willing. Dr. Hadi Bunyamin, there is a direct message for me, and he asks you from Ibu Sri Wahyuni. He asks you about talking about PGBL, project-based learning, and STEM. What learning media is very relevant for implementing the model? What learning media?
Okay, in terms of the media that we can use, okay, definitely, if it depends on the nature or the features of the project. Either it is more like technology based, which is the invention of, for instance, robotics, okay, or it's just having or including the low cost materials. So it depends on the context of the project. If we work with school, which is having not so rich student, okay, and I don't think that we can implement a more like the high technology project with the students. Okay, but yes, if we have a very good students, it means that most of them came from rich family, then we can go for more high tech project, right? But for me, the main medium, the best for me is actually the blended medium or the hybrid medium, where we regularly contact the students, okay, to know the updates of the projects, because it's how we have a consistent communication with the students. But also, don't forget about meeting the students face to face, because I think that's the most effective way on how we can really see the actual progress of the students for that particular project. For instance, if they, for instance, inventing a solar oven that I showed to you, so let him or her bring this solar oven, show to us, show the teachers, and how the teachers can have some immediate evaluation on that particular solar oven. So for me, yes, it depends on the scope of the project, but it should be that for this era, a combination of online environment and also the face-to-face interaction that can boost a kind of the human aspect of that particular project-based learning. I cannot specifically mention on what kind of tools that we can use, because I think for now, I just use a regular technology base, okay? To contact the students, we have the Telegram, we have this WhatsApp or any kind of medium, okay? But I didn't really expect the student to really use the high-tech tools for them to do this project, because I know they have limitations in terms of the finances on their side, especially the parents. Thank you.
Okay, thank you very much, Dr. Hadi Bunyamin. Okay, ladies and gentlemen, we go to the next session. I would like to invite you to questioner to answer the questions. Any questions so far? From Swiss Bell Hotel Palu, please raise your hand. Okay, because the time is almost over, for Dr. Chunyan Chang and Dr. Hadi Bunyamin, maybe I want to hear your closing statement about your research. For the first time, Dr. Chunyan Chang, can you give us closing statement? You still unmute.
Okay,
You
all
still
right.
unmute. Oh, sorry.
Okay, thank you so much for inviting me to this wonderful conference. Although it's a virtual hybrid, but I think I have also learned a lot from not only your question, but also the other speaker, Dr. Hadi. So, and looking forward to maybe meet all of you in person in other occasion. Thank you so much again.
Okay, thank you very much. Dr. Hadi Bunyamin, please, your closing statement.
Thank you very much for inviting me to talk about this particular topic about physics project-based learning. It's really about being a good teacher, even though I'm an academic teaching at university. But being a good teacher, it's something that really need your passion. I really agree with Dr. Chang, okay, for his remark about the importance of passion, okay, your interest, okay, your perseverance in order for you to make the project with the students. And I believe that there's a lot of things to learn, especially those pre-service teachers. You need to know the reality of what happened actually in the school, because otherwise we can be sometimes not really well prepared with this unexpected situation. But for me, it is just challenges and just go through whatever we can do, whatever we can mitigate the problems when we implement this initiative, something that can reform the way we deliver teaching and learning at school. Thank you.
Thank you very much, Dr. Cheng and Dr. Hadi Bunyamin. I would like to express my sincere gratitude to all our speakers and participants for making this seminar a resounding success. Your passion and expertise have enriched our understanding of the complex issues facing education today. As we move forward, let us continue to explore innovative solutions and work towards a more equitable and inclusive education system for all. Thank you very much.
Thank you.
Thank you.
Thank you very much. One important thing, the committee just notified me that they would like to present a certificate of appreciation for both distinguished speakers and right. The certificate should appear on the screen. Certificate of appreciation from the committee for the outstanding recognized teacher of Chun Yan Chang from the next one, please. Yes, the Hadi Bunyamin. Thank you very much for your contribution. We shall proceed to the next agenda. Right, ladies and gentlemen, presenters, important notice from the committee that I would like to point out. Well, first of all, there's an important announcement. Presenters and participants, please make sure you fill out the attendance link to be able to get the certificate. The attendance link has been shared on the WhatsApp group made or created by the committee. It's available there. Please make sure you fill out the link to be able to get the certificate for this conference. Then, for presenters, kindly fill out the confirmation form. Is there a confirmation form from the committee circulated? And this is about payment getting the receipt, you should be able to access the certificate because this is part of the requirement. Well, next one for presenters, still tomorrow, it is required for you to present your work. Thus, you're going to be eligible to get the certificate. So you yourself have to be present tomorrow to present your own paper. And tomorrow, in the second day of ICoPIs, we will begin the conference at 9 a.m. Central Indonesia time. The breakout room distribution can be accessed in abstract book. You have to see that, you have to check it out, because you need to know in which breakout room that yourself belongs to. Important one. And well, a couple of rules to bear in mind with from the committee. First one, you have 15 minutes to present your paper. That's the maximum time, including Q&A, question and answer session. And for online presenters, you are required to use a virtual background. The virtual background, I'm sure it's being circulated by the committee of ICoPIs. Lastly, we expect every presenter to submit full paper. Don't forget to submit your full paper as soon as possible to the committee. Distinguished speakers, presenters, ladies and gentlemen, well, it is important to know, as it's being shown on the screen, it is important to know that the ICoPIs, the international conference today, created or organized by the physics study program, is actually important in line with the vision of the study program, which is to become an internationally accredited study program in the development of physics, education, and science with a focus on environmental sustainability. This is what the study program is concerning on these days. Right? So on behalf of the committee, we would like to extend our appreciation for those who attend the first day of ICoPIs today. To all of you, huge appreciation from the committee. And please be informed for the presenters only tomorrow. We expect your presence to present your own paper. Finally, thank you very much for attending the first day of ICoPIs. And we wish you a very fruitful one in the second day tomorrow. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Tidak perlu kata itu.